Hi everyone, welcome to the class. Welcome. Wholehearted welcome to this amazing session wherein we're going to study everything about definite integration. Tell me, are you all excited? Is everybody on the same page to learn about this amazing concept wherein you're going to have loads and loads of fun and you're going to learn tremendously huge concept and questions. So hello everybody. Hi, how's everyone doing? Hi Samrat, hi Niharika, hello Priyanshu. Everyone give me a quick good to go if you can see me and hear me clearly. Am I perfectly visible and audible to each one of you? Any glitch in the audio video, please tell me quickly. Tell me quickly. I am super excited to discuss this chapter with you and I cannot wait to start the discussion. Can we start? All good? Alrighty. So definite integration, people, is, as you know, one of the highest weightage topics in your JEE Main examination. And you know, as a matter of fact, that there are huge number of questions which get asked in the paper from here in every shift. But let me tell you the good part about this chapter. It is very much within your range to master this topic. If you stick with me throughout this video from start to end, I am guaranteeing you people, I'm guaranteeing you that you are going to face no struggle, no challenge, no pain in cracking questions of DI. Because today I will be bombarding you with number one, supremely high quality questions, be it JEE Main level, be it JEE Advanced level, be it some new questions. Number two, I will be polishing all the concepts of this chapter from start to finish, from basic to advanced. So there is absolutely no scope for you to go blurry with the concepts of definite integration once you leave this video. That's my promise. Once you're through with this live, there is absolutely no chance that you are going to face iffiness in this chapter. That's for sure. All right. Is everyone excited? Everybody, are we all set to dive into definite integration? Guys, you are bound to get 1 to 2 questions from this chapter. That means around 8 marks is the weightage. But if I talk about Leibniz rule, I talk about limit as a sum, I talk about the properties of definite integration, King's rule, so many sub-concepts or subtopics which lie in this chapter get used in other chapters of other units in mathematics. And that is what makes this chapter even more important. It's not like questions from this chapter use the concepts of this chapter. Even questions of other chapters, of other units, definitely use concepts from this chapter. And that is why having a firm grip, a strong command over all these concepts, which I will be discussing with you, is non-negotiable, it's compulsory. It's super compulsory. All right, so everybody, no one is going to take this session today lightly. From the first word I speak to the last word I speak, everything is thoughtful, everything is important, everything is supposed to transfer knowledge to you and give you information. All right, got it? So nobody's going to take even 1 inch of this session lightly. Please sit with your pens and notebooks. Everyone who's here, quickly like the session because that is the way you mark your attendance, and also subscribe to the channel if you have not done that yet. We are very close to our examination, and as you can see, this channel, we are trying our best. In fact, we are doing our best, not trying, we're doing our best to tell you everything, to share with you everything which can help you ace your exams in January. And we're going to leave no stone unturned in making you excel at your performance in JEE Main in January. That is 100% surety. So please subscribe. I don't want you to miss out on even 1 iota of information, of knowledge, of content which might benefit you in future. I don't want you to miss out on even 1 iota of that thing. So please subscribe and definitely hit the like button. If we are all set, I want you to write hashtag HDCC in the chat. Hashtag HDCC in the chat. Everybody, if you're super excited to dive into the discussion of definite integration. Are we? Are we excited? Yes or no? Are we excited? Yup. Should I start? Should I start? Let's go then. Let's go then. Number 1 is the definition. When I say definition, What do you mean by definite integration? Guys, please listen to me very carefully, very, very carefully, because the minute details actually happen to be the slippery area. Have you heard about that saying that devil lies in the details? See, whenever you're traveling on the road, you're walking on the road, let's say. Listen to me, okay? Whenever you're walking on the road, if there is a huge, huge pothole, if there is a huge manhole, in fact, I should say, everybody is able to see that, isn't it? If there's a huge manhole on the road, everybody is able to see that. You are able to see that. I'm able to see that. No matter how busy I am on the phone and I'm walking, no matter how busy I'm daydreaming and walking, no matter how much I'm talking with my friend and walking, I will always be able to see that manhole. It's so big. It can't go unnoticed. But if there is a little speed breaker, if there are one or two stones lying here and there, I may happen to tumble upon them. I may happen to get disbalanced there. That is 100% a possibility. And we all have faced that, isn't it? We all have faced that. So all I'm trying to say is, if there are difficult questions, if there are supremely high-level bouncer questions, it's going to be bouncer for everybody. If there is a big manhole, everybody is going to see it and we're going to jump, we're going to walk past it, right? The chances of us going down the manhole are almost zero. But if there is a little bit speed breaker, if there is here or there's some stones lying, then we may happen to get disbalanced. That means if there are silly mistakes hidden in the question, we are bound to commit them. Not everybody is able to see them, and that is why they are called silly mistakes. So when I say devil lies in the details, these are some small areas which go unnoticed from our naked eyes, from our actually attention, and that is where we commit huge mistakes. And my students, I always say, do not commit these mistakes. We leave supremely difficult questions because everybody is going to leave them. But we are not going to commit these silly mistakes where we may lose marks, we may lose rank, we may fall behind in the race. That is not something my students are going to do. So listen to me very, very carefully. What I am saying is that f is a function which is continuous and well-defined. Both these words are very important. F is a function which is well-defined and continuous on either you can say open interval AB or you can say closed interval AB. Doesn't make a difference. F is a function which is continuous and well-defined on this interval. Then integral f of x dx, let's say, is g of x plus c. What does this mean? What does this mean? This simply means that this g of x plus c, or rather I can say g of x alone, is one of the antiderivatives or primitive or integral of f, isn't it? G is one of the antiderivative or one of the primitive or one of the integral of f. If I add the constant of integration, c, and I keep putting in different real values of c, I will keep on getting different antiderivatives of f. So when you compute indefinite integral of a function, you get as the answer infinitely many functions, infinite family of functions, infinite family of antiderivatives. Are you getting the point? When you compute indefinite integral of a function, you are bound to get infinite answers. They are what? Infinite family of antiderivatives, which are answers of integral of f. But if I attach a lower limit and an upper limit, and now if I compute the integral, what will I get? What will this be? G of x plus c and the limit from a to b. So plug in the upper limit. This b is your upper limit or the superior limit. A is your lower limit or the inferior limit, right? This will give you g of upper limit plus c minus g of lower limit plus c. And when you simplify, you will get g of b minus g of a, which, by the way, people, is a constant. Yes or no? Yes or no? This is a constant. So when you are computing definite integral of a function, that means when you are plugging in lower limit and upper limit, your answers are no more infinite. Your answer is a finite, definite real quantity, which is fixed constant. Getting my answer? That is why the name definite integration, because it gives you a definite answer. Unlike indefinite integration, which happens to give you infinite family of functions as answer. Yup, absolutely correct. The constant of integration vanishes. This C actually vanishes when you plug in the limits, the lower and the upper. Alrighty, cool, but please remember that definite integral of a function can exist within an interval a to b, provided it's well defined and continuous in that interval. So this answer makes sense when f is well defined in the interval ab and continuous in the interval ab. Okay, that's a very important mandatory condition. That's a very important mandatory condition. Remember that. Alrighty. Now tell me, who will tell me what is the geometric interpretation of definite integration? This is where the magic lies. I mean, I seriously love this part of this chapter. What is the geometric interpretation of definite integral? You understood the mathematical meaning, the analytical meaning, right? The theoretical part, as we say. That's also important for us to understand. But how to visualize? How to understand the magic of it? Area under the curve from x equals a to x equals b is Priyanshu's answer. Anybody else? There's a slight mistake in your answer, Priyanshu. Is there anyone who can catch that mistake? Is there anyone who can catch that mistake? Tell me. Very good, Anurag. Very good. UD, yes, you are correct, but tell me, I'm done with the syllabus, left with the conic section and PNC prob. I'm not able to cover these even after putting tons of effort. Then don't worry. See, sometimes what happens when you try to hold sand with your hand and you inside your fist very tightly, what happens? The sand seems to come out, isn't it? But when you hold it using a loose hand, a lot of sand remains there in the hand, isn't it? So don't try to put in that much effort on a chapter which is not your strength. You have to take it a little lightly. When I say lightly, doesn't mean prep lightly. No, I'm not saying that. All I'm saying is start small. Please start small. Start with NCRT, start with solved examples from your module, then move on to PYQs. And don't worry, I will be coming up with these chapters one-shots as well. Please don't worry. I am already planning so much just for you, for your benefit. So please don't worry, stay subscribed and you're going to benefit for sure. Don't worry, but please don't worry. Algebraic sum is the word. What is geometric interpretation of definite integral? When you say integral a to b f of x dx, what does this give you? This bache gives you algebraic sum of area bounded by the curve y equals f of x and the x-axis between x equals a and x equals b. Please understand, bache, when you say numerical value of area, when you say numerical value means absolute value. When you say algebraic value means the original plus minus sign with which it is existing, that is something that we accept and we move forward with. We don't make it absolute. For example, if I say minus 36 and 20, now algebraically 20 is bigger than minus 36, but numerically minus 36 is greater than 20. Why? Because numerically means that you are considering the absolute value. Did you understand? Please get the meaning of the word clear, algebraically and numerically. So here we are considering the algebraic sum of areas. And what does that mean? What does that mean? Algebraic sum of areas. What does that mean? See. Get this straight. Get this straight. Yes, you are correct. Numerically, we compare the mod. Algebraically, we don't compare the mod. We take into consideration the numbers with their original signs, whatever the signs are. All right. So tell me. Tell me. Okay. let me mark, this is your x equals A, this is your x equals B. Is this cool? Is this cool? Now what I'm trying to say is, this is my curve y equal to f of x. Please understand this carefully. Please understand this carefully. When I say what is integral f of x from a to b, it is the algebraic sum of all possible areas bounded between the curve and the x-axis between the two vertical lines x equals a and x equals b. What does that mean? I want this, I want this, I want this, and I want this. Yes? Hi Saranya. Cool. Now let's say this part is 2 units. This is, let's say, 5 units. This is, let's say, 3 units, and this is, let's say, 4 units. This means 2 is the area of the region which is lying below the x-axis, this much part. Okay, but I am going to consider it as -2. Similarly, 5 is the area of the region which is of this mountain that you can see, this much part. I am going to take it as +5. Next is -3. Next is +4. Did you get it? Very good, Priyanshu. Very good. 5 minus 2, 3. 3 minus 3, 0. +4. This 4 is the answer of integral a to b f of x dx. So whatever is the area, you take its algebraic value. You take its algebraic value. Whatever is the area of these shaded regions, you take their algebraic value and you compute the sum. Whatever their original signs are, you take it with that and you compute the sum. If I ask you what is the area, what is the area bounded by the curve and the x-axis, what will you say? You will say, ma'am, 2 units plus 5 units plus 3 units plus 4 units, which is 14 square units. This is how drastically the area and the definite integral actually are different from one another. So whenever somebody asks you what is the geometric interpretation of definite integral, don't just spit out from your mouth that it's equal to area. No. If your curve is lying above the x-axis throughout from a to b, then definite integral will be equal to the area. Then definite integral will be equal to the area. But if some portion of your curve is lying below x-axis, some portion of your curve is lying above the x-axis, then definite integral will not be equal to the area. Okay? Is that cool? Is everything #HDCC till here? Whenever you are computing area, bachche, you are always interested in absolute value. So if this much portion is -2, you will consider mod of -2, which is 2. The next portion is 5, already above the x-axis, so +5. Next is 3 below the x-axis, so -3. Its mod will be 3. Next is 4, already plus, so +4. This is your area. So when you consider area, you consider everything in absolute sense, numerically. Cool? Is this clear? So drastic difference between area and definite integral. Everything making sense? For example, if I say this is pi by 2 and this is 0, this is sine x curve. Okay, so if I say integral 0 to pi by 2 sine x, what will this be? Minus cos x. Minus cos x from 0 to pi by 2. Tell me quickly. Tell me quickly. This is 0 minus 1. So your answer is 1. This much part is bachche 1. The area is also 1 square unit and definite integral is also 1. Why? Because the curve is lying above the x-axis. Similarly, if I ask you this 0 to pi by 2 cos x. What is the answer? Very good, Priyanshu. Very, very good. Very, very good. Again, if you compute 0 to pi by 2 cos x dx, this will give you sin x from 0 to pi by 2. Okay? Which will again give you 1. So please remember, from 0 to pi by 2, definite integral of sine is 1. Definite integral of cos is also 1. But this is also equal to the area because the curves are lying above the x-axis. Yup. All cool? All good? Perfect. Now tell me one more thing. Let's say I consider 0 to 5 pi by 2 sine x. Can you tell me the answer? I've tweaked things a bit. 0 to 5 pi by 2. Can you tell me? Can you tell me? This is 0, this is pi by 2, this is pi, this is 3 pi by 2, this is 2 pi, and this is 5 pi by 2. You just now saw that this portion was 1, this portion 1, this one due to symmetricity, this is also 1. What is the answer? Quick, quick, quick. Quick. 1 plus 1 minus 1 minus 1 plus 1, the answer is 1. But if I ask you area, oh my God, what is area? Area is 1 plus 1 plus 1 plus 1 plus 1, which gives you 5 square units. That's the fun part. That's the fun part. All right. If I ask you 0 to 5 pi by 2 mod sine x dx, what will you say? What will you say? Mod sine x dx, it will be this much, then this much, then this much. Yes or no? Yes or no? What happens? What happens when you take mod of a function? What happens? Whatever is above the x-axis remains as it is. Whatever is below the x-axis, you flip it about the x-axis. That's how you trace the graph of mod function. So 0, pi, 2 pi. Correct? 1 plus 1, 2, 1 plus 1, 2, and this is 1. Did you understand? This is 5. Absolutely correct. Absolutely correct. So now have you understood what is the meaning of definite integral of a function from a to b geometrically? Everything cool? Everything cool, guys? Is it cool? Any confusion? Anybody tell me right now. Stop me right now. Tell me right now. Shall I go ahead? Perfect. Perfect. Let me start with number 1. Look here. Integral a to b f of x dx. Okay? Integral a to b f of x dx. Integral a to b mod of f of x dx. Can you tell me what is the relationship between these three quantities? What is the relationship between these three quantities? Anybody, any idea what is the relationship between these three quantities? First is integral of a function from a to b as it is. Next is its mod value. Next is definite integral of the mod function. Anybody, any clue what is the relationship between these three quantities? Tell me quickly. It's not that difficult. It's not that difficult. See? See? This is, let's say, A, this is, let's say, B, this is, let's say, 2, this is 4, and this is 1. Okay? And your curve is y equal to f of x. And your curve is y equal to f of x, right? If I consider a to b f of x dx, what is this? 2 minus 4 plus 1, right? Definite integral, plain definite integral I'm computing. 2 minus 4 is minus 2, minus 2 plus 1 is minus 1. If I consider mod of integral a to b f of x dx, that means mod of this answer. So mod of minus 1 is simply 1. Mod of minus 1 is simply 1. But if I consider integral a to b mod of f of x dx, what does this mean? This means first of all my graph now will look like 2 as it is, 4 is this, and then there is 1. So 2, 4, 1. Correct? So integral a to b mod of f of x dx is equal to 4 plus 2, 6 plus 1, 7. Making sense? Making sense? So that means you can clearly see this is the least, next is this, next is this. And that is why this is the relationship between these three quantities. You as it is know, if I talk about this part, you as it is know x is less than equal to mod x for every x real. So integral will always be less than equal to its mod value. Whatever is the value of the integral, it can be plus or minus, right? Definite integral of any function can come out to be a plus value or a minus value. It will always be less than or equal to its mod value, no? Because mod will make it absolute, it will be greater than or equal to. And if I talk about the latter part, this is the most important part. Mod of the integral is less than equal to integral of the mod. You can't believe, even when you do bachelor's, master's in mathematics, this result comes in so handy. It is used tremendously. Mod of the integral is less than equal to integral of the mod. Mod of the integral is less than equal to integral of the mod. Mod of the integral is less than equal to integral of the mod. Extremely important property. You can even check it using this example. See, integral of sine x came out to be 1. But when you computed integral of mod sine x, it came out to be 5. So integral of sine x was 1. Its mod is again 1. Mod of 1 is 1. But integral of mod sine x is 5. Okay? Understood? So be it through graph here or be it through the sine example, I hope the first property is very clear. Is this clear? Is this clear? Cool. Let me go to the next one. Let me go to the next one. Integral a to b f of x dx is valid provided f is well defined and continuous between a and b. Between a and b. Why and how is this property so important? See, if you consider pi by 4 to 3 pi by 4 tan x dx. Can you say that you can directly compute the definite integral of this function from pi by 4 to 3 pi by 4? Can you do that? Answer. Can you do that? Is it even possible? Can you do that? No, I can't do that because there is a pain point between pi by 4 and 3 pi by 4 lies a pi by 2, and that's a problematic point because tan is not defined at pi by 2. Tan pi by 2 doesn't exist as a well-defined real quantity. Of course, it's discontinuous at pi by 2 because it's not defined at pi by 2. So what do we do in such situation? Because pi by 2 is a problematic point, this is where we split the integral. That's the approach. What do? You take pi by 4 to pi by 2. This time you are going from pi by 4 to pi by 2 from the left hand side plus pi by 2 to 3 pi by 4. Now you are going from pi by 2 to 3 pi by 4 from the right hand side. Okay, that's why there is a minus and a plus. Very, very good, Priyanshu. Super impressive. Super impressive. So whenever your integrand, this is your integrand function. Whenever your integrand function is discontinuous or not defined at any point C between A and B, what do? You split the integral at C. Okay, and you write it as sum of piecewise integrals. Integral from A to C plus C to B. Integral from A to C, then C to B. If there are multiple points at which your function is discontinuous or not defined, then you break the integral at each of those points. Got it? Very good. Very good. Please remember this. Let me take another example. Okay, let me take this example. I is equal to integral minus 1 to 1 d by dx of cot inverse 1 by x. Yes, answer. Come on, answer. Quick, guys. If you are getting the concept, please answer. This is the foundation going on. If the foundation happens to be weak, no matter how much you excel at properties or question solving, you will never be able to get that confidence that I know this chapter in and out. I know this chapter from start to finish. I know this chapter from every depth. Tell me quickly, how will you be cracking this question? First of all, you know integral and differentiation are inverse of each other. If you start solving this directly, there is a trap. Directly means integral and differentiation cancel each other, inverse of each other. You will be left with just cot inverse of 1 by x, limit from minus 1 to 1. Right? Ideally. But this is wrong. Why? Because between minus 1 and 1, again, Between minus 1 and 1, there is a 0, which is the problematic point. When you plug in x as 0, 1 upon x is undefined. Right? So you can't find cot inverse of an undefined quantity. Yes, absolutely correct. So what do you have to do is, ideally, what do you do? Yes, okay, integral and differentiation are inverses of each other. You can cancel, but in a smart way. What will you do? Tell me quickly, what will you do? You will write minus 1 to 0 d by dx of cot inverse 1 by x dx. Correct? Plus 0 to 1 d by dx of cot inverse 1 by x dx. You will split your integral at 0, bachche. You will split your integral at 0. Okay, cool. Now you will find in the next step cot inverse 1 by x from minus 1 to 0 plus cot inverse 1 by x from 0 to 1. How does the graph of cot inverse behave? Like this. This is pi, this is pi by 2 and this is 0. Cool? Cot inverse x. Now tell me, please tell me, this is 0 from the negative, this is 0 from the positive. Very interesting, very interesting. Very interesting. See, this is your rectangular hyperbola, which is the graph of 1 by x. Just see how I'm visualizing. It's so interesting. When x approaches to 0, from the left hand side, your 1 by x is approaching to minus infinity. So you are getting cot inverse of minus infinity when you plug in the upper limit. When you plug in the lower limit, you get cot inverse of 1 upon minus 1, which is minus 1. Did you understand? What did I do? Yes. Next is cot inverse of 1 minus cot inverse of what? When you approach to 0 from the right hand side, 1 by x approaches to infinity. Perfecto. Perfecto. What is the next step? What is the next step? What is cot inverse of minus infinity? You can clearly see from the graph. You can clearly see from the graph, as we move towards minus infinity, cot inverse moves towards pi. And what is cot inverse of minus 1? Anybody? You already know tan inverse minus 1 plus cot inverse minus 1 is pi by 2. Tan inverse minus 1 is minus pi by 4, right? So cot inverse minus 1 is pi by 2 plus pi by 4, which is 3 pi by 4. So pi minus 3 pi by 4 plus, what is cot inverse 1? Come on. Cot inverse 1 again in the same way, na? Tan inverse 1 plus cot inverse 1 is pi by 2. So pi by 2 minus pi by 4 will give you again pi by 4. And what is cot inverse infinity? See, as the input is approaching to infinity, your cot inverse is approaching to 0. What is the answer? The answer is pi by 2. Please check. I have a big smile on my face because I feel this is supremely important and this is supremely beautiful. Just appreciate the fact that because my function, my integrand was not well defined at certain input lying in between my extreme limits, I had to break my integral there. I had to split my integral there into two distinct integrals, or I had to write my integral as the sum of two piecewise integrals. Cool? This is the beauty, bache. This is the beauty, and now I'm moving ahead and talking about another property. See, one or two properties are very obvious which you are already well versed with. I don't think I need to tell you. For example, the property that a to b f of x dx is equal to integral a to b f of t dt. You know this? Independent of change in variable. Your definite integral is independent of change in variable. You write whatever alphabet, they are all dummy variables. X is varying from a to b, or t is varying from a to b, u is varying from a to b, v is varying from a to b, w is varying from a to b. I don't care, I don't give a damn. My definite integral is independent of change in variable. Cool? Let me talk about this one. Integral a to b f of x dx is minus integral b to a. Interchanging limits. When you interchange limits, it happens at the cost of a minus sign. When you interchange limits, it happens at a cost of minus sign. Cool. Let me talk about the next property. So these two are very easy. Very easy, very simple to comprehend. But there is a property which now is supremely important. Listen to me and you will answer. If I say integral a to b f of x dx is 0, what do you understand from here as a conclusion? There are two very important conclusions of this situation. If your integral of f from a to b happens to be 0, what is the conclusion that you are able to understand? When can this happen? When does this happen? Integral f from a to b is 0 means what? Means what? Anybody? Yes, Priyanshu, you're close. Close. Hit the nail right on the head. Come on, hit the nail right on the head. Yup. See, whenever integral f from a to b is 0, one possibility is that a is equal to b. If your lower limit and upper limit happen to coincide, you can clearly visualize there is a graph from a to b, but actually a and b are the same. So what is the area swept? It is 0. Obviously, it's 0, right? That is one very direct, very obvious, very natural conclusion. But there is another conclusion. Yes, you are correct, Priyanshu. Absolutely correct. Hit the nail right on the head. Perfect. Bingo. Next conclusion is that a1 minus a2 is 0. What does this mean? What is the meaning of a1 minus a2 is 0? I'll just explain you the meaning. Listen to me carefully. If you want your function to get your definite integral as 0, this means what? If a is not equal to b. If a is equal to b, then to pakka 0. If a is not equal to b, a and b are two distinct quantities lying farther away from each other. And the graph of f has to then behave in such a way that when you add the algebraic sum of areas, you happen to get a 0. It's but obvious that your graph should somewhat look like this. Yes or no? Let's say this is your A. Let's say this is your B. It should look like this in such a way that whatever is the positive area, same is the negative area, magnitude wise. Let's say this is A1, let's say this is A2. Because A1 and A2 are matching in magnitude, but one is above, one is below, so obviously your integral from A to B f of x dx will come out to be what? A1 plus A2. But actually A2 is nothing but minus A1, so this is 0. Yes or no? Yes or no? Here I can write A2 is equal to minus A1. Is this cool? Is this understood? Okay, for example, I can draw another graph. See, suppose I draw this. Listen to me carefully, okay? This, and this. Listen to me carefully. This is A, this is B. 5 units, 4 units, 3 units, 4 units. Look here. Look here and tell me what is the definite integral. A and B are two distinct quantities. A and B are two distinct quantities, and if you start computing integral A to B f of x dx, what is the answer coming out to be? Plus 5 minus 4 plus 3 minus 4, 8 minus 8, 0. Why 0? What is making the integral 0? That some portion lies above and some portion lies below. In fact, the portion which lies above and below actually have the same magnitude. So one thing is sure, if A is not equal to B and my integral is coming out to be 0, then definitely some portion of the graph will have to lie above, some portion will have to lie below. In fact, both of them will have to have B of the same magnitude. Moreover, the graph will have to cut the x-axis at least once. It can either cut the x-axis exactly once, or it can cut the x-axis multiple times. But at least once it will definitely cut the x-axis. This is called root theory, bache. This is one root. These are all roots. Making sense? Absolutely correct, Priyanshu. So there are not 2 but 3 conclusions. There are not 2 but 3 conclusions. What are the 3 conclusions, guys? Are you able to understand? Let me quickly write the 3 conclusions here. One is, when your integral comes out to be 0, one very obvious basic conclusion is that your limits are equal. Very obvious. Second conclusion is that your A2 is equal to minus A1. What does this mean? Understand what is A2 equal to minus A1 means. It means whatever is the magnitude of the area above the x-axis, same is the magnitude of the area below the x-axis. The magnitude is the same. Of course, one with a plus sign, one with a minus sign. When you will add them algebraically, the answer will come out to be 0. But how do you visualize it? Whatever is the area above the x-axis, same is the area below the x-axis magnitude-wise. And thirdly, if f is continuous in AB, then there exists at least one root of f between A and B. This is, bachche, what is called your, what did I say? Root theory. This conclusion is specifically very important. Very important. Hi, Crystal Cuddle. Nice name, such a cute name. Okay. Did you understand, everybody? Because if my A and B are different and I want 0 to be the answer of my integral, some portion of f will have to lie above, some lie below. For the function to lie above and below, it will have to cross the x-axis at least once. No. Cross the x-axis at least once means the function, if it is continuous, will have a 0, at least one 0 between A and B. Okay, here is the catch. The catch is the word continuous, bachche. The catch is the word continuous. I don't have space, I'll use this space. Why is the catch continuous? Because let's say I have this graph. Listen to me carefully. Let's say I have this. This is your A, this is your B. You can clearly check whatever is the area above the x-axis, same is the area below the x-axis. So, if suppose the magnitude of this is A1, magnitude of this is A2, if I consider integral A to be f of x dx, if I consider integral A to be f of x dx, it will obviously be A1 and then plus A2, but A2 is minus A1 only, so 0. But integral is 0. A is not equal to B. Integral is 0, but there is no root. There is no root. Why is there no root? Because the function is not continuous in A and B. In between, it is breaking. You can see the curve. Did you see the curve? The curve is just from here to here and then break here to here. Because of the flaw in continuity, there is no root even when the integral is 0. So please understand, the catch is continuous. The catch is continuous. The function has to be continuous. All right? All right? Okay? Chalo. Let's go to the questions now. This is your first question, guys. I have explained you the theory. There is one result left which I will explain you just in a short while. But before that, I want you to attack this question. This is integral from A to B, e to the power x by a minus e to the power b by x whole upon x dx. Fantastic question. Fantastic question, guys. I want you to please brainstorm. Brainstorm upon this. Think what is the approach you will use to crack this integral. And out of the 4 given options, which one do you think is correct? Quick. Anybody, any clue? Notes you will get once the live is over. Once the live gets over, I will definitely be sharing with you the notes. And I guess once the live is over, after 1 or 2 hours, you get the notes. 100% you will get the notes. Don't worry about it. Detailed notes. Tell me quickly. Anybody, any clue? See, it's integral a to b e to the power x upon a minus e to the power b by x whole upon x dx. Yes, on Telegram. This is your I. I need to calculate I. What do you think I will do? Come on. Okay, the hint is The hint is use the technique of substitution. This is not a very easy question. This is not a very low-hanging fruit type of a question which you can just jump and grab very easily. No. You will have to brainstorm upon the perfect substitution that you can use to crack this integral. What do you think will it be? If I substitute x equals ab by t, will that work? Come on, dx equals ab as it is minus 1 by t square and dt. Yes or no? Yes or no? So my I will be equal to what? Integral a to b. When you plug in x as a, what will come? B. When you plug in x as b, what will come? A. So these are the limits of t now, that which is our new variable. E to the power x by a. E to the power x by a will be b by t. And e to the power b by x. Come on, tell me. Tell me, what is b by x? This means b upon ab by t. So this is t by a. Whole upon x, which is ab by t. And dx is minus 1 by t square dt. Wow. T cancels out. It is minus 1 by t square dt into ab. There is ab as well. So this ab also cancels out. What are you left with? I comes out to be equal to minus of integral b to a e to the power b by t minus e to the power t by a upon t dt. Because of this minus sign, I can interchange my limits. Because of this minus sign, I can interchange my limits. So I will make this minus sign vanish from a to b. I have always told you definite integral is independent of change in variable. Now I can, in place of t, use x. What will this give me? Integral a to b e to the power b by x minus e to the power x by a upon x dx. And what is this? Absolutely correct. What is this, bache? What is this? Come on. Look here. E to the power x by a minus e to the power b by x. E to the power b by x minus e to the power x by a. This is nothing but minus I. Yes or no? I is equal to minus I. That means 2I is 0, which means I is 0. Bingo. All right. Is this cool? Everybody hashtag HDCC. The magic here was of substitution. This is the perfect substitution. This is the perfect substitution. That's why we are practicing, Priyanshu. That is why we are practicing, so that whenever you find questions like these where you have x upon a, b upon x, something upon something is the substitution which is going to work. But what upon what? That's why we are working upon this. Of course, you can very well calculate that much in your head that, okay, I have x upon a and b upon x. So something upon something will work. But what upon what? That's what I'm teaching you, Ankit. Please don't get overwhelmed. This is just the first question. By the end of this live, by the end of this entire video, you are going to become a pro at DI. Just the beginning. Make a star at the substitution dabba. Make a dabba around substitution. Make a star and write there what? Very important. Please write very important. You have to come back to this substitution even later whenever you revise. Now, before I move on to the next question, let me share with you a very nice property. This is the last thing I want to share before we jump on to the actual king's rule, queen's rule, whatever. Please understand, this is one of the fundamentals which you must not miss. The property says, if f is positive in AB, then integral a to b f is also positive. If f is negative in AB, then integral f is also negative. Is this obvious to you? If suppose the graph of f lies above x-axis between a and b, then obviously the integral will come out to be positive only. If the graph lies below the x-axis between a and b, then obviously the integral will also come out to be negative, because the integral is the algebraic value of the area. So here the algebraic value is positive, here the algebraic value is negative. So when the graph is above the x-axis, integral is positive. When graph is below the x-axis, integral is negative. But what I wish to convey to you through this property is, but converse is not true. Converse is not true. If your integral is positive, if the integral of a function from a to b is positive, does not imply that the function is throughout lying above the x-axis. That is not the implication, bache. If the function's graph is lying above the x-axis, integral, yes, will be positive. If the function's graph is lying below the x-axis, it's negative, definite integral will be negative. But if the definite integral is positive or negative, doesn't mean the function will be positive or negative. Absolutely correct. For example, let me draw this. See, this let's say is 4 units, this is 2 units. Okay, what is the integral? This is y equal to f of x. This is your f of x curve. So this is a, this is b. Integral from a to b f of x dx is coming out to be plus 4 minus 2, which is 2. Integral is positive, but the function throughout is not above the x-axis. It simply means, when the integral is positive, it simply means that the area swept above the x-axis is of a larger magnitude than the area below. If the definite integral comes out to be negative, it means the area below x-axis is of larger magnitude than the area above. But it does not compulsorily imply that the entire graph will lie above or the entire graph will lie below. There is a possibility of it cutting the x-axis, as you can see from the diagram. Cool? Chalo. This was the last thing I wanted to share, and now shoot questions on you guys. Look at this one. For any real number x, let this denote GIF of x. This is one area which scares students a lot. Please tell me in the chat, how many of y'all are genuinely scared of GIF functions or integrals involving GIF functions, greatest integer functions? How many of y'all are shit scared? Yes? Kirtika? Quickly tell me. How many of y'all are shit scared? Yes, ma'am? No, ma'am? Yes, ma'am? No, ma'am? Almost every second student is having struggle, facing challenge in decoding the GIF functions. Especially when it comes with the integral, life becomes hell. Today, I will make it supremely simple for you because there is a 3-4 step algorithm, or rather a 2-3 step algorithm which you must follow to crack questions based upon GIF functions. Let's start with an example. Before I move on to the question, let me share with you an example. Suppose I have GIF of sine 2 pi x dx from 0 to pi. How do you think you will solve this? So rather, let me make this 2 pi and let me make this x. Tell me. Quickly tell me. Thank you. Thank you. Tell me. If you draw the graph of GIF function, I hope you know, what is the situation? 0, 1, 2, 3 and so on and so on and so on and so on. It's like a step function which is having jump discontinuity at every integer. At every integer, it is discontinuous. It's breaking at every integral input. This is the graph of GIF of x. Wherever the inside quantity is an integer, there it's breaking or becoming discontinuous. That is why this is the only idea you have to apply, you have to use, you have to implement. What? Wherever my inner quantity will be an integer, that is where I will be breaking my integral, because that is where my inner quantity will be discontinuous. Alright, so sine x is an integer where all between 0 and 2 pi. That is the only thing you have to check. Very good, Ankit. High five. High five. I can do like this, a virtual high five. You can send me an emoji and do a high five. See, where all is my sine x integer? Sine x can be either 0 or 1 or minus 1. That's it. These are the only possible integers it can take, right? That means when x is 0, pi by 2, pi, 3 pi by 2, 2 pi, minus pi by 2 and so on, right? Yes or no? Between 0 and 2 pi, that means I want x to be 0, pi by 2, pi, 3 pi by 2 and 2 pi. Cool? That's it. You will be integrating your function from 0 to pi by 2, then pi by 2 to pi, then pi to 3 pi by 2, then 3 pi by 2 to 2 pi. So the 0 to 2 pi integral will break into 0 to pi by 2, pi by 2 to pi, pi to 3 pi by 2, 3 pi by 2 to 2 pi. That's the only catch. Now, between 0 and pi by 2, here you will write GIF of sin x dx. Here also GIF of sin x dx. Here also GIF of sin x dx. Obviously, that's the integrand. That's the integrand. But the good part is, when x is 0, sin is 0. When x is pi by 2, sin is 1. Yes? So my inner quantity in 0 to pi by 2 is varying from 0 to 1. So the GIF will be 0. At pi by 2, sin is 1. At pi, sin is 0. So here, between pi by 2 and pi, my inner quantity is ranging from 0 to 1. Again, the GIF will be 0. At pi, sin is 0. At 3 pi by 2, it is minus 1. So my inner quantity here is ranging from minus 1 to 0. The GIF will be minus 1. At 3 pi by 2, it's minus 1. At 2 pi, it's 0. Again, ranging from minus 1 to 0, GIF will be minus 1. Answer. Done. Dusted. End of the story. We do this, right? Done and dusted. Done and dusted. Awesome then. If this is clear to you, I hope this is absolutely clear. Now let's attack the question. My I is 0 to 10 GIF of under root of 10x upon x plus 1. Very interesting question, people. Very interesting question. What will you do? What will you do? Now, inside my GIF, the quantity sitting is this one. Where all is this becoming an integer is my quest. That is my chase. So see, under root 10x upon x plus 1. This can either be a 0 or a 1 or a 2 or a 3 and so on. The under root of something cannot be negative. No. Integers are negative also. But under root of something cannot be negative. It can always be non-negative. I 20, Ankit 180, Kirtika 20. What are the options? Okay, there is no option. Cool. Acha, I is 20, 9i is 180, you are saying. Chalo, let's see. So this means, if I start with 0, I get 10x upon x plus 1 is 0, which implies x is 0. Okay. Now, when I say under root 10x upon x plus 1 is 1, this means this is 1. So, which implies 10x is equal to x plus 1, which implies 9x is 1 or x is 1 by 9. Perfect. This is another input. I want inputs between 0 and 10. Remember, I want all those values of x between 0 and 10, wherein my inner quantity sitting inside the GIF is an integer. Next is under root 10x upon x plus 1 is equal to 2. So this will be 4. This implies 10x is equals to 4x plus 4. So this gives you 6x is equal to 4. X is equal to 4 upon 6, that is 2 upon 3. Again, accepted. Accepted. Next is 10x upon x plus 1 square root is equal to 3. 0 happened, 1 happened, 2 happened. Now let's go to 3. 3 means the square when you take this will be 9. So you are getting 10x is equal to 9x plus 9, which implies x is equal to 9. Oh. If I take under root 10x upon x plus 1 to be equal to 4, which is the next input, here I will get 16. And this will give me a negative x. This will give me a negative x. I can't accept negative x because I want x between 0 and 10. That means that's it. We are exhausted. My acceptable values of x are 0, 1 by 9, 2 by 3 and 9. So where all will you break your integral? Tell me. 0 to 1 by 9, next 1 by 9 to 2 by 3, next 2 by 3, 2 by 3 to 9 and lastly is 9 to 10 because I want 0 to 10. I want 0 to 10, na? Understand, this is 0, this is 10. In between I am breaking at 1 by 9, 2 by 3 and 9. So how many piecewise integrals? 1 from 0 to 1 by 9, next 1 by 9 to 2 by 3, 2 by 3 to 9 and then 9 to 10. Yes? Is this cool? Is this cool? Now, when you plug in x as 0, your entire inner quantity is 0. When you plug in x as 1 by 9, your inner quantity is 1. That means your inner quantity is ranging between 0 and 1. So, here the answer will be 0. Next, at 1 by 9, it's 1. At 2 by 3, it's 2. So, between 1 by 9 and 2 by 3, it's ranging from 1 to 2. So, GIF will be 1. Next, at 2 by 3, it is 2. At 9, it is 3. So, it's ranging between 2 and 3. GIF will be 2. Next, at 9, it's 3. At 10, it's greater than 3. So, between 3 and greater than 3, but less than 4. This means the GIF will be 3. What is the answer? Everybody tell me quickly. What is the answer? Come on, come on. This is 2 by 3 minus 1 by 9 plus 2 times 9 minus 2 by 3 plus 3 times this. 6 minus 1 is 5 by 9. Then I have 9 into 3, 27 minus 2 is 25 by 3, 50 by 3. And then there is 3. Tell me quickly. 9, then there is 5, 50 into 3 is 150, this is 27. 155 plus 27, 182 upon 9 I am getting. I am getting 182 upon 9. Are you getting 182 upon 9? Are you getting 182 upon 9? This is the value of I. I is 182 upon 9. So, 9I is nothing but 182. Answer is wrong. I is not 20 and 9I is not 180. Guys, where have you slipped? Where have you committed a mistake? Please catch hold of that step. I have just done one thing which I even explained you even in this example. Where all is my inner quantity? Inner quantity means the quantity sitting inside GIF. This is my inner quantity or inner function. Wherever my inner function becomes an integer, that is where I split my integral. So, if I am integrating from 0 to 2 pi, I am interested in those values of x between 0 and 2 pi where my inner function is becoming an integer. Similarly, here, this is my inner function. Under root of 10x upon x plus 1. Between 0 and 10, whatever is the value of x between 0 and 10, which is making my inner function integer, that is where I will be breaking my integral. Like at 1 by 9, 2 by 3 and 9. From 0 to 10, so I get 4 integrals. 1, 2, 3 and 4. Is this clear, guys? Very important question. You can see it's a PYQ. Questions like these have been asked in JEE Advanced and now they are occurring in JEE Main. So the trend has become quite escalated. The trend has become quite escalated. All right. Let's go to the next question. What does it say? F from R to R be a function defined like this. Again, GIF. Today I'm going to make you a pro at GIF. If I is this, what is the value of 4i minus 1? Anyone? Any clue? Anyone, any clue? F of x is given to you and look at the integral that you are interested in. Minus 1 to 2 x into f of x square upon 2 plus f of x plus 1. There are primarily two functions you are concerned with. One is f of x square and other is f of x plus 1. And what you are given is f of x. So using f of x, can you work on the definition of these two functions? Of course. And please don't forget, you only need to work in the interval minus 1 to 2. This is my interval of interest. I am not interested to go beyond this. Replace, absolutely correct. F of x is given to you as GIF of x whenever x is less than or equal to 2 and 0 whenever x is greater than 2. So when you, instead of f of x, write f of x square, this will be GIF of x square whenever x square is less than equal to 2 and it is 0 whenever x square is greater than 2. Now you know the graph of x square, right? You know the graph of x square. Cool, this is 2. When you say x square is less than equal to 2, carefully, this is minus root 2 and this is root 2. When you say x square is less than equal to 2, that means it's greater than equal to 0, less than equal to 2. That means x is sandwiched between minus root 2 and plus root 2. Now root 2 is nothing but 1.414. Yes or no? I am interested in minus 1 to 2 and this is what? Minus of 1.414. I am only interested in minus 1 to 2. Minus 1 to 2. So here I will say my x belongs to minus 1 to root 2. Actually, x square less than equal to 2 implies that x belongs to minus root 2, say root 2. But what is my accepted range within this interval? Tell me. Minus 1 to root 2. Right? I will intersect this with my interval of interest. What I will get is minus 1 to root 2. So this much I am removing. I will write here x greater than minus 1 less than equal to root 2. And whenever x square is greater than 2, x square greater than 2 means what? X square greater than 2 means what? X is greater than root 2 or x is less than minus root 2. Now intersect this with minus 1 to 2. What will you get? What will you get? You will get x belongs to root 2 comma 2. Yes or no? Very obvious, bache, very obvious. X is greater than root 2 or x is less than minus root 2. But I want to intersect it with minus 1 to 2 interval. That is my only interval of interest. So within that interval, what are the inputs where x square is greater than 2? The inputs are root 2 to 2. That's it. Root 2 to 2. So x lies between root 2 to 2. This is f of x square. All right. But again, when you say minus 1 to root 2, you can further break this up. No, minus 1 less than x less than equal to 0. Yes or no? Minus 1 to 0, then 0 to 1, then 1 to, let this be 0, this be 1, let this be 1 and this be root 2. And here I will get x is greater than root 2 less than 2. Tell me quickly. I am interested in getting the exact value of GIF. Tell me. When x is lying between minus 1 and 0, x square is lying between 0 and 1. The GIF is 0. When x is lying between 0 and 1, again x square is lying between 0 and 1. The GIF is 0. When x is lying between 1 and root 2, x square is lying between 1 and 2. The GIF is 1. And here the answer was as it is 0. So instead what I can do is, because I'm getting 0 twice, instead what I can do is I can play smart. I can very well play smart. 0 when x is sandwiched between minus 1 and 1. It is 1 when x is sandwiched between 1 and root 2. And it is 0 when x is greater than root 2. Is this making sense? Is this making sense, everybody? Cool. So f of x square is sorted. Now I want f of x plus 1. If I talk about f of x plus 1, again guys, same story. GIF of x plus 1 whole square. GIF of x plus 1 whole square, provided x plus 1 is less than equal to 2. And it is 0 when x plus 1 is greater than 2. X plus 1 less than equal to 2 means x is less than equal to 1. And this means x is greater than 1. This is just x plus 1. But you know, as a matter of fact, GIF of x plus 1 means GIF of x plus 1. Yes? GIF of x plus 1 overall is GIF of x plus 1 separately, because 1 is an integer. You can pull it out of the GIF sign. Correct? Now again, less than equal to 1. X less than equal to 1, this means ideally this represents what? X belongs to -1 to 1. Because I am interested only in -1 to 2 interval. Remember? And greater than 1 means this ideally represents 1 to 2. Perfect. Perfecto. Now, if you are between -1 and 1, there are two situations. You are between -1 and 0, then 0 to 1. So, this you can further write x is greater than -1, less than equal to 0. And here you can write 0, 1, and here you can write 1 and then 2. So, between 1 and 2, so it's 0. But if x is lying between -1 and 0, GIF of x will be -1. -1 plus 1 will give you 0. If x is lying between 0 and 1, GIF of x will be 0, plus 1 will give you 1. Okay? Okay, okie dokie. Yes. So now you realize where all am I breaking my integral, because eventually I need to integrate from -1 to 2. See, this is -1, this is 2. So -1 to 1, 1 to root 2, root 2 to 2. -1, 1, root 2. -1, 1, root 2, or I can say -1, 0, 1, root 2, 2. -1 to 0, 0 to 1, 1 to root 2, root 2 to 2. These are all the possible piecewise integrals in which I am breaking my actual integral, which is -1 to 2. I want -1 to 2. What do I want? X times f of x square. Remember, x times f of x square upon 2 plus f of x plus 1. 2 plus f of x plus 1 dx. Now, as I said, -1 to 0, 0 to 1, 1 to root 2, root 2 to 2. Is this cool? 4 integrals, 4 piecewise integrals, guys. Now, -1 to 0, let's see. X times f of x square. -1 to 0, f of x square is 0. I don't care whatever f of x plus 1 is, because this is completely 0. Done and dusted. What about 0 to 1? What about 0 to 1? 0 to 1, again f of x square is 0. Okay, x into 0 upon 2 plus, I don't care what f of x plus 1 is, because this completely is 0. 1 to root 2. 1 to root 2, f of x square is 1. So, x into 1 upon 2 plus, what is f of x plus 1? 1 to root 2, it is 0. Alright, this much I can integrate. Root 2 to 2. Root 2 to 2, again my f of x square is 0. I don't care what f of x plus 1 is. Perfect. This is also 0. Such a brilliant question. You're only left with this integral. This is integral 1 to root 2 x upon 2. Can you calculate? Can you calculate? The answer is what? The answer is what? 1 by 4. Are you getting this as the answer, everybody? 1 by 4 is the answer. Question says 4i minus 1. 4i minus 1. 4 times 1 by 4 minus 1 will give you 0. Are you getting 0? Big fat 0. Is that the answer you're getting? Brilliant question, bache. If these type of questions, if you're not able to crack, at least in the practice session, it's a big pain point. Why? Because I am not saying you attempt these questions in the first go in the exam, because here a lot of analysis is required. A lot of analysis is required, that in what intervals am I going to break my original parent interval? In whichever interval I am working on, what is the value there? How am I substituting? Where is the equality sign or strict inequality sign? All these things are supremely important, but if I talk about that pressure situation under which you are in the exam, definitely you can have decision paralysis. Definitely you can freeze. Definitely you are bound to make some mistakes here and there in such questions. But don't attempt them in the first go. But in the practice sessions, did you understand all the entire flow? All the steps, did you understand? Were you able to capture what I was explaining? Because the flow has to be clear, the concept has to be clear, the soul of the question has to enter inside you. The soul of the question should go inside you, because this question can come in the exam in a tweaked fashion, in maybe a shorter fashion, in maybe which you can crack in a quicker way. But you should understand the idea behind it. That's non-negotiable. Okay? Alrighty. Now let's come to this question. This is something which is fab. Why is this fab? This was asked in JEE Advanced 2022. Hi Naveen. This was asked in JEE Advanced 2022 and this is based upon a beautiful, very beautiful result. This is based upon a beautiful result. Do you know what that result is? Do you know what that result is? It was asked in Advanced 2022 and it holds great possibility to land in your JEE Main exam in 2025, January. The result is this, bache. This is a beautiful result, very important result, a result which not many people know. And I want all of you all to grab this, write this in your notebook and please make a dabba around it. Not many people know. Look at the result. If you know this result, you can crack this advanced question in the snap of a finger. What does it say? If G is the inverse of F and domain of F is entire interval A to B such that F of A is C and F of B is D, then integral A to B F plus integral C to D G is BD minus AC. Must remember. Must remember. Please note this down and I am not asking you to cram. What is written? G is the inverse of F. So F inverse is nothing but G. I am integrating from A to B. See, I'm going to prove this result for you. Consider the left hand side. This is your left hand side. Consider this. So integral A to B F of X dx plus integral. What is C? C is F of A. And what is D? D is F of B. What is G of Y? It is F inverse Y dy. Yeah, I'm proving this for you. Can you tell me how can I proceed further? Can you tell me how can I possibly proceed further? Can you tell me? Tell me. No, it's okay. If you are confused between X and Y, you can just do one thing because these are just dummy variables. Consider X here, consider X here. What you do is, again, I'm waiting for someone to tell me. This X you take as F of T. Substitution. Dx will come out to be F dash T dt. But eventually, this left hand side will get converted to A to B F of X dx plus integral. When X is F of A, T is simply A. When X is F of B, T is simply B. And this is F inverse of F of T, which is T into F dash T dt. Very good. Now what you have to do is a catch step. Write this into one and apply by parts. Yes, folks, let's apply by parts. I'm going to solve it here itself. Let's solve it here, apply by parts. Can I start? Okay. First function, integration of second from A to B minus integral of differentiation of first into integration of second dx from A to B. And already what is written? Plus integral A to B T times F dash T dt. You write X times F dash X dx. Not a problem. And you can clearly see this and this gets cancelled out. What are you left with? You are simply left with B times F of B minus A times F of A. This is your answer. F of B is nothing but D. F of A is nothing but C. This is your right hand side, which you were supposed to prove. Hi Shasha. Nice name. You started with left hand side, you ended up getting the right hand side. Please remember, I'm sharing the proof with you so that this result is cemented in your head. It's ingrained in your system. You have to digest it right now. F is the inverse of G. Then integral from A to B F plus integral of its inverse from F of A to F of B is equal to A times B times F of B minus A times F of A. Tell me, quickly tell me, is this clear? Integral F from A to B plus integral F inverse from F of A to F of B is B times F of B minus A times F of A. Is this clear? I'm repeating this again. integral f from a to b plus integral f inverse from f of a to f of b is equals to b f of b minus a f of a. Tremendously important result, people. Cannot afford to take this for granted. There is a JEE Advanced 2022 question asked just upon this result directly. If you know the result, you can apply it and get the answer in fraction of a second. My name is Bhoomika Ma'am. You can join me on Telegram. The group is Study with Bhoomika Ma'am. Okay? If you're not there still on Telegram, do come. Alrighty, look here then. Look here, carefully. See, this is your A, this is your B. Is the color visible? Is the color visible? Color is visible, bacha? Let's say this is A, let's say this is B. I want to check, is this f of A, is this f of B? Where this integrand function is f, and my claim is that this integrand function will come out to be f inverse. See? Let's start. If my A is 1, my B is 2, what is my f of 1? It is log 2 cube 8 is 9 to the base 2. Perfect, perfect. This is my f of A, and f of B is log f of, okay, this is 1. No, 1 plus 1 is 2. Log 2 to the base 2 is 1. And this is log 9 to the base 2. This is perfect. This is perfect. Perfecto. What about the inverse? If my f of x is log of x cube plus 1 to the base 2, let me take this as y. So what will I get? 2 to the power y is equals to x cube plus 1. So 2 to the power y minus 1 to the power 1 by 3 is actually x, which is nothing but f inverse y. Or rather I can say f inverse x is equals to 2 to the power x minus 1 raised to the power 1 by 3, which is exactly the integrand I am searching. No. Yes or no? That means this question is actually matching the format of my result. Yes or no? It's matching. No. Integral a to b f of x dx plus integral f of a to f of b f inverse x dx. The answer is b times f of b minus a times f of a. So what is b? 2 times. What is f of b? Log 9 to the base 2. Minus what is a? 1 times. What is f of a? 1 times. So this is 9 square is 81. So log 81 to the base 2 minus 1. Log 81 to the base 2 minus 1. Tell me, is this clear? You want to see the proof slide. Is this clear? Proof slide, guys. See the proof. It's very simple. I don't think there's any problem with the proof. Is this clear? 5 is the answer? Yes, I guess 5 is correct. I guess 5 is correct. Please see this. Log 81 to the base 2, I can write 1 as log 2 to the base 2. Log m minus log n is log m by n to the base 2. And 81 by 2, tell me. 81 by 2 is 40.5. Chalo, cool. Now you know 2 to the power 5 is less than 40.5 is less than 2 to the power 6. If you apply log throughout, you will get 5 is less than log 40.5 to the base 2 less than 6. That means this quantity is coming out to be sandwiched between 5 and 6, and that is why the GIF is going to be 5. Hashtag HDCC everybody. Such a brilliant question you can crack in a jiffy if you know this result. It's a fantastic result, and let me tell you, not everybody knows this, not everybody teaches this. Of course, there is a conventional method to crack this question as well, but I want you to understand that if you just remember this result, this advanced question, cracking it is a cakewalk. It's literally a cakewalk. It's like child's play. Very easy. Easy peasy lemon squeezy. But remember the result, it's not very difficult to remember. Integral a to b f plus integral f of a to f of b f inverse is equal to BFB minus AFA. Done and dusted? Done and dusted. The answer is 5. Done and dusted. ऐसा emoji नहीं होता? Do we have an emoji like this which does done and dusted? I don't know if there is an emoji or not. If there is, let me know in the comments. Okay, dokie then. I'm super excited. Let me show you the next question. This is going to blow your mind away. Why? Oh, nice. Yup, I like this. F of x is max of mod x plus 1, mod x plus 2, mod x plus 3 and so on till mod x plus 5. I want to integrate f from minus 6 to 0 very clearly this question is shouting out loud to visualize. Please visualize me. Please imagine me. Please draw my graph. Let's draw then. This question is demanding graphical approach. 100%. Very good, Priyanshu. Awesome job done. Awesome job done. When I say mod x plus 1, how do you plot this? How do you plot mod x plus 1? Tell me. Mod x graph, you know, is this. Mod x graph, you know, is this. When you shift this graph to the left by 1 unit, you get mod x plus 1. So your mod x plus 1 graph will look like this. This is your mod x plus 1 graph. Cool. This point is minus 1. This point is 1. Mod x plus 2. When you shift the mod x graph to the left by 2 units, you get mod x plus 2. This is minus 2. This is 2. Mod x plus 3. Different color. This is 3. Fine. Mod x plus 4. Fine. Mod x plus 5. This is 4. This is 5. Shasha, bachche, please understand. When you have mod x, what do? This is the graph of mod x. If you want to draw the graph of mod x minus 1, you will just shift this graph to the right by 1 unit. Okay? If you want to draw the graph of mod x plus 1, you will shift the graph of mod to the left by 1 unit. Just remember this much. We have studied this in transformation of graphs or play with graph section. If you don't remember, just remember this much. This is your f of x. When you draw f of x minus 1, your graph shifts to the right horizontally along the x-axis by 1 unit. When you draw f of x plus 1, your graph shifts to the left along the x-axis horizontally by 1 unit. Okay? Now tell me, I want max of all these graphs. I want max of all these graphs. Please understand, how am I going to attack this? How am I going to attack this? How? Very, very good. See. Please see this. This is the line x equal to minus 3. Why am I drawing this line? Because I want you to realize that before x equal to minus 3, no matter what section you take, the max will always come out to be this graph. Yes or no? Please check. No matter what section you take, you want from minus 6 to 0. So minus 6 will lie somewhere here. Between minus 6 and minus 5, largest is this yellow line. Yes or no? Largest is this yellow line. Between minus 6 and minus 5. Between minus 5 and minus 4, again yellow line is the largest or the one lying at the topmost. Between minus 4 and minus 3, again yellow line. So every time before minus 3, the topmost graph is this yellow line. This is the max. The one which lies at the topmost is the max. What about after minus 3? After minus 3, this is the max. After minus 3, no matter what section you take, the red line will always come at the topmost. The red line will come as the topmost. Is this clear? Is this clear? So if I want to integrate from minus 6 to 0, this is 0. If I want to integrate from minus 6 to 0, I will integrate from minus 6 to minus 3 and then minus 3 to 0. Because from minus 6 to minus 3, I have a different function. It's the yellow line. From minus 3 to 0, I have a different function. It's the red line. Now, what is this yellow line? Look, very carefully look, yellow line. The yellow graph was mod x plus 1. This is equal to, I'll write from the yellow pen only so that you can understand. This is mod x plus 1. This is equal to x plus 1 when x is greater than equal to minus 1 and minus x minus 1 when x is less than minus 1. So when x is less than minus 1, the definition is minus x minus 1. What about the red graph? The red graph is mod x plus 5. So this is x plus 5 when x is greater than equal to minus 5 and minus x minus 5 when x is less than minus 5. So right now it is greater than minus 5. So my definition will be x plus 5. This is x plus 5. Yeah, you can do that also. That only I am doing. That is the thing that I am doing. See, what I am doing is, I'll show you. You are saying trapezium. No, I'll do the same thing. This is mod x plus 1 minus x minus 1 and here it is x plus 5. Correct? I want from minus 6 to 0. So understand, here somewhere is minus 6. Alright, here somewhere is minus 6. Listen to me carefully. This is your minus 3 and this is 0. So technically you want the areas of 2 trapeziums is what Priyanshu is saying. No, this is 1 trapezium, ma'am. This completely is 1 trapezium whose area you need, and next is minus 3 to 0. Next is your minus 3 to 0, which is this trapezium. This is the next area, ma'am, that you need. So if I add the areas of both these trapeziums, I'm going to get my answer, right? Let's say this is A1 and let's say this trapezium's area is A2. Now what is A1, what is A2, guys? Let's see. What is A1 plus A2 is what I need. So half into sum of parallel sides. Sum of parallel sides. When you plug in x equal to minus 6 over here in this definition, minus x minus 1, you will get 6 minus 1, 5. 5, okay, so this length is 5. Understand? This complete length is 5 units and this length is what? Tell me quickly. Again, plug in minus 3, you will get 3 minus 1, 2. This length is 2 units. So 5 plus 2. Half into sum of parallel sides into height. Height is 3 units. A2 will be what? Half into sum of parallel sides. Sum of parallel sides, which is 5 plus again this is 2 into height is again 3. Area is not clear. Why not clear? What is removed? Is something removed or you can see the areas clearly? There are 2 trapeziums. There are 2 trapeziums. Get this straight. There are 2 trapeziums being formed. Everybody, is it clear? 21 upon 2 plus 21 upon 2 gives you 21 as the answer. Making sense? Shasha, have you understood how 2 trapeziums are being formed? Plus 4. Congratulations then. High five. Awesome job done. Let's go. Let's go to the next part, which is, look behind me, is the supremely important high weightage King's property, guys. So we are through with our basics. I hope you understood how to crack questions which come in the exam from the fundamentals of definite integration. We've spent good amount of time to clear our basics, to clear our fundamentals. I hope that much part is absolutely crystal clear to you. If it is, write hashtag HDCC in the chat, which Priyanshu has already done. Very, very good. Now let's dive into the King's property, something which we all, I think we remember it by heart. Even if I wake somebody up in the middle of the night, from the middle of their sleep, and I ask them, what is King's property? I'm sure people will be able to tell. I'm sure people will be able to tell. Yes or no? Yes or no? So let's go. What is King's property? Very simple. 0 to a f of x dx is 0 to a f of a minus x dx. And if the limits are not 0 to a, they are from a to b, then technically you replace this x with a plus b minus x. Is it cool? You replace x with a plus b minus x. The integral's answer does not change. The integral's answer does not change. Very, very, very good. The answer does not change. You integrate f from a to b, or you integrate f of a plus b minus x from a to b, the answer does not change. For example, if you take this as t, you take a plus b minus x as t, you get minus dx equal to dt. So your right hand side will become integral. When you plug in x as a, this will be b, this will be a, this is f of t into minus dt. But this minus sign will interchange the limit. I will get a to b f of t dt, which is same as a to b f of x dx, which is my left hand side. Okay? Okay, so I started with right hand side, I proved it equal to the left hand side. This is the proof of my King's rule. Always remember, here also the same thing is happening. This is like a, this is like b. So a plus b minus x, 0 plus a minus x will give you a minus x. Okay, so what's written on top is a particular case of what's written on the bottom. This is your King's property, bachche. This is your King's property. Let me now share with you the even odd property. I'm going to tell you 3 properties together and then we'll jump onto the questions based upon them. Even odd property. Everybody, listen to me carefully. Even odd property. Chalo. What does this say? Even odd property. It says integral minus a to a f of x dx. Very good. Integral minus a to a f of x dx is 0 if your integrand is odd. It is 2 times integral 0 to a if your integrand is even. And if your integrand is nino means neither even nor odd, then bachche you apply King's rule. Then you apply King's rule. Remember, the even odd property comes into action, comes into play, gets activated when your limits look like minus a to a, minus 1 to 1, minus 2 to 2, minus pi to pi. Whenever you have limits which are symmetric limits, minus 1 to 1, minus 2 to 2, minus 3 to 3, minus pi to pi, that's when you have to recall the even odd property. It should strike your memory. It should knock the doors of your memory very, very hard. Hard knock on the doors of your memory. Even odd property, even odd property, even odd property. Whenever the limits look like minus a to a. Check the integrand. If the integrand is an odd function, what do you mean by odd function? F of minus x is equal to minus of f of x. This is an odd function. It's symmetric. The graph is symmetric about origin, or the graph is symmetric with respect to opposite quadrants. If I say even, it means f of minus x is equal to f of x. So an even function is symmetric with respect to the y-axis. Okay, it's symmetric with respect to the y-axis. If your integrand is even, what will be the integral? 2 times 0 to a. Because it's symmetric with respect to the y-axis, whatever is the area before y-axis from minus a to 0, same as the area after y-axis from 0 to a. So you are adding the area from 0 to a 2 times. That's the logic, right? And if your function is nino, if your integrand is nino means neither even nor odd, then you apply King's rule over your integral and proceed further. Making sense? Is this cool? Any doubt, anyone, any confusion? Very important property. Let's apply it here. For example, if you get minus 2 to 2 x square sine x, you know x square is an even function. Sine x is an odd function. Product of an even and an odd function is definitely an odd function. This is completely an odd function. So the answer will straight away be 0. If I talk about mod x is, you know, an even function. This is an even function. The graph is symmetric about the y-axis. Whatever is the area from minus 2 to 0, same is the area from 0 to 2. No, understand. This is minus 2, this is 0, this is 2. So whatever is the area between minus 2 to 0, same is the area between 0 to 2. So this will be 2 times integral 0 to 2 mod x dx. But in 0 to 2, mod x is same as x. Is this difficult? High definition, crystal clear. Okay, what about this mod sin x? Tell me, how will mod sin x look like? in minus pi to pi? Tell me. Quickly tell me. Minus pi to pi, this is mod sine x. Minus pi, 0, pi. Clearly, it's an even function. Symmetric about y-axis, you will write 2 times integral 0 to pi mod sine x. Yes, ma'am, no, ma'am. But in 0 to pi, mod sine x is same as sine x. So mod sine will be removed and you can solve this further. Easy peasy. Easy peasy. Sometimes what happens, you don't directly get an integrand which is either even or odd. Your integrands, some part is even, some part is maybe anything, neither even nor odd, or some part is odd and some part is neither even nor odd. For example, this one, you can write as minus 2 to 2 x cube dx plus minus 2 to 2 x square cos x dx. See, x cube is an odd function. Minus 2 to 2 integral directly is 0. X square cos x, you know, is an even function because this is even, so product is even. Your answer will be 2 times integral 0 to 2 x square cos x dx. Now you apply by parts, that is your headache. Now you apply by parts and solve this integral, that's your headache. But what I'm trying to say is, sometimes your integrand doesn't completely fall in one category of being even or odd. Some part of it can be even or odd, that you can solve separately, right? And some part will require a proper integral approach. So that much you have to do. Making sense? But there are questions of Nino category as well. For example, this one. Here you can see the integrand is this. This is neither even nor odd, bache. Neither even nor odd. If you plug in x as minus x, you take the integrand as f of x. Now you plug in x as minus x. F of minus x will not be equal to minus of f of x. And f of minus x will not be equal to f of x. So this is neither even nor odd. What will you do? Take this as I and now apply King's rule. Please apply King's rule. You will get I is equal to minus 2 to 2. Minus 2 plus 2 minus x. That means you replace x with minus 2 plus 2 minus x, which is minus x. A plus b minus x. No. A plus b minus x, right? Okay. If you're new, you should know HDCC means high definition crystal clear. Okay, 1 upon 1 plus e to the power minus x dx. What is this? Minus 2 to 2, 1 upon 1 plus 1 upon e to the power x. So this will give me what? E to the power x here and 1 plus e to the power x here. This is your 2, this is your 1. Both are i's. You add both of them. 2i is equal to what? Integral minus 2 to 2, 1 plus e to the power x upon 1 plus e to the power x dx. Very standard, very standard. What does this give you? Tell me. Minus 2 to 2, 1 dx. Quickly tell me. Is this clear? Is this clear? This is an even function. 1 is an even function. So 2 times integral 0 to 2, 1 dx, which means 2 times x from 0 to 2. This will give you 4 as the answer. Not clear means, is video not clear, guys? Please tell me. Absolutely correct, Priyanshu. Absolutely correct. Please tell me, is the video absolutely clear? Is there any problem with the video or the audio? It's clear, right? No problem, no glitch, no iffiness. Alrighty. Let's go now to the next thing, which is the Queen's property. Okay, we are through with the King's rule. We are through with the even odd property. Now it's time for the Queen's property. This is not very important. Let me quickly tell you, this is a minor property. This is a minor property which gets used in between the questions. So your primarily your integral will be of, let's say, based upon King's rule or even odd property or some other major concept. And in between, while solving in some intermediate step, this property comes into play. That's why this is not a very important major property, but you must know what it does. What it does, what is its agenda, what is its duty, what is its dharma. It is used to break limit into half. That's its duty. Whenever you wish to break your limit into half of what it is, then you use the Queen's rule. Please understand, look here carefully at the result, see what it says. check what it says. It says integral 0 to 2a f of x dx is 2 times integral 0 to a. Your upper limit was 2a, now it is half of 2a, which is a. So you have broken your limit into half. Twice integral 0 to a f dx if f of 2a minus x is f of x. What is the meaning of this? What is the meaning of f of 2a minus x equal to f of x? Anybody who knows? What is the meaning? Absolutely correct. What is the meaning of f of 2a minus x equal to f of x? Please tell me. It means f is symmetric about a. When the graph of f is symmetric about a, in mathematical language you write it as f of 2a minus x equal to f of x. So this happens to be the mathematical condition, but if you want to visualize, it means f is symmetric about a. In that situation, you break the limit into half. 0 to 2a becomes twice of 0 to a. And if that doesn't happen, that means f of 2a minus x is minus of f of x, then the answer is 0. Alright, for example, integral 0 to pi sine x. 0 to pi sine x, you know sine of pi minus x is equal to sine x. Here the role of 2a is being played by pi. That means I want to check whether my sine graph is symmetric about pi by 2 or not. And that is correct. This is 0, this is pi. My function is symmetric about a. 2a is pi, so a is pi by 2. My graph is symmetric about a. 0 to pi by 2, whatever is the area, same is from pi by 2 to pi. That is why you can write this as 2 times integral 0 to a sine x. Is this cool? And 0 to pi by 2 you know is 1. 1 into 2 will give you 2. But 0 to pi cos x. Remember 0 to pi cos x. It's very simple. You can clearly see from the diagram, whatever is above, same is below. The answer will come out to be 0. But if I have to apply the Queen's property and check, then cos of pi minus x is equal to minus cos x. And that is why with respect to the Queen's property also, the answer is coming out to be 0. Periodicity condition, I will come to periodic properties as well. Priyanshu, please don't worry. This is an intermediate property, a very minor property. It comes into action in between the question. For example, look at this question. 0 to pi sec square x upon tan square x. Please listen to me very carefully. Right now, pi is playing the role of 2a. Okay, listen to me carefully. If you look at this integrand, sec square x upon 1 plus tan square x, you know this is familiar to you. What do you end up doing? You take tan x equal to t, which implies sec square x dx is equal to dt. Can you do so? Can you do this here or not? Sec square x dx will be dt, fine. 1 plus tan square x will be 1 plus t square, fine. What about the limits? When x is 0, tan 0, 0. When x is pi, this is also pi. So 0 to 0, whatever is the integrand, I don't care, my answer will come out to be 0. Oh Baba, what happened? Can this answer come out to be 0? No, a big fat no. Why, ma'am? Because this complete integrand, bachche, is positive upon positive, which means positive. And when your function is positive, that means the graph is lying above the x-axis, then integral f from a to b is also positive. So if your complete integrand is lying above the x-axis, its integral will be positive. It cannot come out to be 0. So what will you do? You have to check that between 0 and pi, at pi by 2, my function is not defined. At pi by 2, my function is not defined. My tan function is not defined. How can I assume it to be equal to t in the entire interval 0 to pi? That's a crime. Very good. Break it at midpoint. Which is pi by 2. But how do you do that? See, you consider pi to be 2a. So 0 to 2a integrand. Now see, this is your f of x. If you check f of pi minus x, this will come out to be equal to f of x. Yes? Hi Srimeda. Hello Akshat. Of course. 100%. That's why we are taking one shots. Starting from scratch to the most advanced level. This is cool. So I will write this as 2 times integral 0 to pi by 2 sec square x upon 1 plus tan square x dx. This is how the Queen's property comes into play. In between, sometimes directly, sometimes indirectly. Got it? Now everything is sorted. Now you can take tan x as t because now the interval is 0 to pi by 2. In that entire interval, tan is defined, and then you can say sec square x dx is dt, and then proceed further. Yes? Yes, you've broken it up. You've broken it up, but using the Queen's rule. This is your Queen's rule that you are using. Because f of 2a minus x is equal to f of x, you are breaking it up as twice of integral 0 to a. Okay? Cool. So we are through with King's property, even odd property, Queen's property. Let's go to the questions now. JEE Advanced 2019. You are left with a couple of more properties, Naveen. Don't worry. We are doing one bit, then applying it in the questions, doing another bit, applying it in the questions, then doing another bit, applying it in the questions. This is how we'll proceed with the class. So that there is nothing, there's no burden or there is no overflow of concepts in the head. You have to understand, apply, understand, apply. That's how we have to proceed. Because you have to keep cementing what we are learning. There is something, there's a saying in Hindi, aage part, piche sa part. So you're moving ahead, trying to learn new stuff without digesting the old stuff. So you're putting in the new and the old is getting decayed. The old is getting vanished. Okay. You want a break? Okay. In 10-15 minutes? Let's complete this topic before we start the periodic property. I'll give you a break. What to apply? Come on, quick. What to apply? What to apply? Come on, come on, come on. What to apply? Quickly. What to apply? You can clearly check. If you look at the integrand, this is 1 upon all of this. Bache, this is a NEET function. Neither even nor odd. And that is why what you're going to do is apply the King's rule. Right? I is 2 upon pi integral minus pi by 4 to pi by 4. 1 upon 1 plus e to the power sin x 2 minus cos 2x. All of this dx. You will apply the King's rule now because your integrand is a NEET function. Neither even nor odd. King's rule means replace x with minus x. Why? A plus b minus x. Minus pi by 4 plus pi by 4 minus x will give you minus x. बहुत बढ़िया. Very good, Priyanshu. High five, yaar. Hats off. You must remember what Priyanshu is saying, but I will first prove it to you, then give it to you as a takeaway. Here, another I, right? 2 upon pi minus pi by 4 to pi by 4. Replace x with minus x. 1 upon 1 plus e to the power sine of minus x, which is minus sine x. 2 minus cos 2 into minus x, which is cos of minus 2x, which is same as cos 2x. Cos is an even function. Doesn't bother. Now, e to the power minus sine x is 1 upon e to the power sine x. This is 1 upon e to the power sine x. When you compute the LCM, you are left with 1 plus e to the power sine x. And on top, there is another e to the power sine x. This is second, this is first. After applying the King's rule, we always add the original and the new integral. Both are I only. So you end up getting 2i is equal to 2 by pi integral minus pi by 4 to pi by 4. You have 1 plus e to the power sine x upon 1 plus e to the power sine x 2 minus cos 2x dx. Is this cool? This is what Priyanshu was saying. always this 1 plus e to the power sine x, this exponential term gets cancelled. Always. You don't have to do all these steps. Without performing all these steps, if you are through with this question now, from this point onwards, remember, there's no need to perform all these steps. Your 1 plus e to the power sine x, this part, whenever it occurs in the question, after applying the King's rule, adding both the integrals, it gets cancelled out. Now that you know the steps, you can kind of do some mental math in the paper also, or anytime a question like this appears before you in your mock test, in your class test, wherever, you can do a bit of mental math and kind of foresee that, okay, this part will get cancelled out after 3 steps. Okay, this 2 cancels out. I comes out to be 1 upon pi integral minus pi by 4 to pi by 4, 1 upon 2 minus cos 2x dx. Guys, the magic is, after applying the King's rule, the magic that happens is that your integrand generally comes out to be either an even function or an odd function. This time it is an even function. Because it's an even function, I can write it as 2 times 0 to a. Remember, even odd property, integral minus a to a, if the integrand is even, is twice integral 0 to a. Okay? Okay? Cool. So this will be 2 times integral 0 to pi by 4. I hope this step is clear. Now you will get I pi upon 2, or pi I, write it pi I. Pi I upon 2, this is integral 0 to pi by 4, 1 upon 2 minus cos 2x dx. Can you solve this? Can you solve this? I have pi I upon 2, integral 0 to pi by 4, 1 upon, this is 2 minus cos 2x dx. Can you simplify this? Can you help me simplify this? What do you think? Whenever your integrand looks like 1 upon a plus b cos x, what do you do? What do you do? 1 upon a plus b cos x. What do you do? Quick. 1 upon a plus b cos x, what do you do? What is the hack? What is the substitution? What is the approach? What is the direction in which you have to proceed in order to compute this integral? You will write cos 2x is 1 minus tan square x upon, very good Priyanshu, 1 plus tan square x. Okay, so cos 2x you're writing as 1 minus tan square x upon 1 plus tan square x. Right? Now what? Now what? Can I take tan x as t? Yes, ma'am, you can take, because your x is lying in the interval 0 to pi by 4 and your tan function is completely well defined and continuous in the interval 0 to pi by 4. That is why substitution here is allowed. It's valid. It's valid. So sec square x dx is equal to dt. Now let's proceed. When x is 0, t is 0. When x is pi by 4, this is 1. So 1 upon 2 minus 1 minus t square upon 1 plus t square, and dx is sec square x dt upon sec square x dx is dt. हाँ, ठीक है. हाँ, तो 1 plus tan square is here, na? So let me write it like this. 1 minus tan square, and here it will be 1 plus tan square. Now 1 plus tan square is sec square. So sec square x dx completely will be dt. And here what do you have? You have 2 minus 1 minus t square. Capital T is tan square, small t is the substitution. So 2 minus 1, 1 plus t square. Is that what you're getting? Oh yeah, LCM. So 2 plus 2 tan square. Got it. 2 plus 2 tan square minus 1 minus tan square. Cool till here? Cool till here? So 2 tan square plus tan square, 3 tan square plus 1. 3 tan square plus 1. Is this what you are getting? 0 to 1 dt upon 3t square plus 1. This is t square. Okay? Fine? Fine till here. Capital T is representing bachche tan and small t is the substitution. Tan x equal to small t. Now what? 3 comes out. 1 by 3 is nothing but 1 by root 3 whole square. Yes or no? 1 upon x square plus a square is 1 upon a tan inverse x upon a limit from 0 to 1. So root 3 upon 3, this is 1 by root 3. This is tan inverse of root 3t from 0 to 1. Tell me. So you are getting root 3 pi I by 2. Cross multiply. No, this thing you send to the left hand side. Left hand side was pi I by 2. So root 3 pi I by 2. Root 3 pi I by 2 is equal to what? Tan inverse root 3, which is 60 degrees, minus tan inverse 0, which is 0. 60 degrees is pi by 3. So I is coming out to be pi cancels out 2 by 3 root 3. So if you want I square, it is 4 upon 3, 3s are 9, 3s are 27. So 27 I square is equal to 4. That's the answer. Oh, you want break? Let me give you a break then for 10 minutes. Is 10 minutes okay? Is 10 minutes fine? Yes, 4 is the right answer. Shall we meet sharp at, let's say, okay, 8:20? Let's meet at 8:20. 8:15ish to 8:20, I'm going to be back. Okay, this is break. Let's break for a break. Okay, cool. Chalo, let's come back after the break. Alrighty, folks, we are back. Back with a bang. Everybody who is still not here, please come back quickly. Call your friends, call everyone. We're going to continue solving questions based upon King's rule, even odd property, and also the Queen's property. So let's go, everybody. Are you back? Are you back? All good, all cool? I'm going to continue with the next question. This one was from JEE Advanced 2019. Let's go to the next question, people. This is again a very old JEE Advanced question. Now, these type of questions which have been asked in JEE Advanced now hold very high probability to land in your JEE Main exams. Because now, obviously, the approach to crack these questions is very much familiar to a lot of kids. Okay? If you ignore the question while you are practicing, just because it's of advanced level or it had appeared in the advanced exam, you're committing a big mistake. Because very old advanced questions hold huge probability to repeat in the JEE Main exams. Very recent JEE Advanced PYQs, I won't suggest hold that much high chance of repeating in your JEE Main exam, but old JEE Advanced PYQs are now again and again and again repeating in your JEE Main exams. So make sure you solve those questions, and I will make sure that you solve those questions. So let's go. 0 to pi by 2, 3 times root cos theta upon root cos plus root sine to the power 5 d theta. What do you think is the scene here? How exactly will you be able to crack this question? Tell me, what is the approach? Again, if you look at the integrand, bache, if you look at the integrand, this is your integrand. Again, you will realize it's of Nino category, neither even nor odd, neither even nor odd. What will you do? What will you do? Tell me. 100% we will apply the King's rule. What is my I? I is 0 to pi by 2, 3 times root cos upon root cos plus root sine to the power 5 d theta. This is 1. Apply King's rule. You will get 0 to pi by 2, 3 times root over cos of 90 minus x. Tell me. Cos of 90 minus theta is sine theta. Whole upon root over sine theta plus root over cos theta to the power 5. I have just applied King's rule, bache, nothing fancy. Second step has come after applying the King's rule in between. Any confusion? I've replaced x with pi by 2 minus x. So my first equation is my original given integral, and my second equation is actually the integral which I've obtained after applying the King's rule. Replace theta with pi by 2 minus theta. Replace theta with pi by 2 minus theta. Now add both the i's. What will you get? You will get 2i equal to 0 to pi by 2. And what is above? 3 root cos upon 3 root sine. Yes or no? Tell me. You have 3 root cos upon plus 3 root sine whole upon root cos plus root sine to the power 5 d theta. So obviously 1 will get cancelled out. You're left with 2i equal to 0 to pi by 2, 3 times root cos plus root sine to the power 4. How do you think now you will resolve this integral? Huh? How do you think now you will resolve this integral? Very famous, very common. Please understand, you have 2i by 3 is equal to integral 0 to pi by 2, 1 upon root over cos theta plus root over sine theta raised to the power 4 d theta. Tell me, how will you crack this integral? What is the approach? Very standard integral, bache, very standard. These type of integrals keep popping up in between in your intermediate steps. Very standard integral. How will you crack? How will you crack? Tell me. By converting into tan. Whenever you have sine and cos in the denominator, you will always convert them into tan. To convert them into tan, what will you do? But obvious, you will take out root cos to the power 4 common. Now cos to the power 1 by 2 raised to the power 4 means cos square. 1 upon cos square will make this sec square. So sec squared theta. upon 1 plus root over tan theta raised to the power 4. This is your new integral. This is your new integral. What next? This is your new integral. Now what next? Will you take tan theta as t? Or will you take root over tan theta as, let's say, t square? Or will you take 1 plus root tan theta as t? What? What do you think is the right substitution? I've given you 3 choices. This one, or this one. Please tell me. See, students are going to think in all directions. Top, in the numerator, I have sec squared theta d theta. So taking tan as t is but obvious. But with what combination? Will I take just tan theta as t? Under root will become 1 plus root t raised to the power 4. If I take root tan as t square, I will get 1 plus t square whole to the power 4. Right? Both are non-favorable situations. That means most favorable situation is taking 1 plus root tan as t. Entire denominator, let me take as t. Okay? When you take 1 plus root tan as t, what do you end up getting? Tell me, this is root tan. That means tan to the power 1 by 2. So you get 1 upon 2 root over 1 root over tan theta into sec squared theta d theta equal to dt. Yes or no? Please tell me yes or no. This much part is done. So your integral converts to what? Tell me, when theta is 0, tan 0, 0. This gives you 1. When theta is pi by 2, what will you do? Pi by 2. Infinity. This is infinity. Sec squared theta d theta is dt into 2 root tan theta. Root tan theta is t minus 1 upon t to the power 4. That's it. 2 into t minus 1 dt. Is this clear or not, guys? Please tell me. I am doing nothing. I have just brainstormed upon 2 things. Number 1, when I had sine plus cos in the denominator, obvious approach was to convert things into tan. When I did that, I as a result got sec squared theta d theta on top, and in the denominator I got 1 plus root tan raised to the power 4. My mind started moving in 3 directions. Should I take tan as t, or root tan as t square to get rid of the square root, or 1 plus root tan complete denominator as t? And I realized the most profitable situation, the most beneficial situation is taking 1 plus root tan as t. When I did that substitution, accordingly changed dx to dt, accordingly changed my limits. Tell me, is there any confusion from here? Any confusion? All cool? All cool, because you're almost done. You are getting 2i by 3. 2i by 3 is equal to 1 to infinity, 2 common, t minus 1 upon t to the power 4 dt. Okay, so this 2 cancels out. T minus 1 means what? 1 to infinity, t upon t to the power 4 means 1 upon t to the power 3. So t to the power minus 3 dt minus t to the power minus 4 dt. Yes or no? This is I by 3. This is I by 3. So I by 3 is equal to what? T to the power minus 3 plus 1 upon minus 3 plus 1, 1 to infinity, minus t to the power minus 4 plus 1. So minus 3 upon minus 3 from 1 to infinity. Tell me. Quickly tell me. Is this cool? So I by 3 is equal to minus 1 by 2. Now what? What is t? T is 1 plus tan theta raised to the power half. So 1 plus root tan theta. Quick. What will you get? Come on. T is infinity. T is infinity. Come on. What will you get? Will you get 0 minus 1? And here, when you get plus 1 by 3, again 0 minus 1. Yes, ma'am, no, ma'am? And hence, I by 3 will come out to be what? This is 1 by 6. So, I comes out to be 1 by 2. Is this cool? Is this cool? T is nothing but 1 plus root tan. T is nothing but 1 plus root tan. Yes, ma'am, no, ma'am? Huh? Yes, ma'am, no, ma'am? When theta was pi by 2, t was ranging to infinity. So, plugging in t as infinity is equivalent to plugging in theta as pi by 2. Okay. Fine. Is this question done? This was again a Nino category question. Now comes a question which is absolutely amazing. This is literally amazing. One of the most favorite questions, if you ask me. Most favorite. Why? It says f of x is equal to integral 0 to 1 t to the power minus x 1 minus t to the power x minus 1 dt. What is f dash half? The problem with this question is what? I'll tell you, whatever is the problem with this question, same is the beauty of the question. The problem or the beauty, put it anyway, 0 to 1 t to the power minus x 1 minus t to the power x minus 1 dt. Understand, these are the limits of t with respect to which you are integrating. Dt means t is the variable of integration. So, limits are over t. But x here is sitting like a constant. Right now, in this integrand, x is behaving like a constant. When you will solve this integral, your answer will come out in terms of x. When you solve this integral and plug in the values of t as 0 and 1, what you will get as the answer will be a function of x. You keep on plugging in different values of x, you will keep on getting different answers. So basically, when you solve this entire integral, it will come out to be a function of x is what is the primary step to understand. Is it cool? Is it cool? But my integral is with respect to t, the limits are over t. So right now in the integrand, my x is kind of behaving like a constant. So when now I am going to apply King's rule, my King's rule will be applied on the variable of integration, which is t, which implies I will replace t with a plus b minus t, 0 plus 1 minus t. This is what I will do. I will not touch x, I will not disturb x. My variable of integration is t. So when I will apply my King's rule, I will apply it on t. I will replace t with a plus b minus t, which will give me 1 minus t. Okay, so what will I get? F of x is equal to 0 to 1. T will be replaced with 1 minus t minus x as it is. 1 minus again 1 minus t, x minus 1 and dt. Okay. 1 minus 1 plus t. This will give me t to the power x minus 1. T to the power x minus 1 dt. Alrighty. Okay. This is my f of x. This is my f of x after applying the King's rule. Okay. What if, now this is the catch. The major catch is this. If in the given equation, I replace x with 1 minus x. What will I get? I will get f of 1 minus x is equal to, limits are over t. That is not going to change. I am just replacing x with 1 minus x. T raised to the power minus of 1 minus x. 1 minus t raised to the power 1 minus x minus 1. So this will give me minus x. And minus 1 plus x means x minus 1. Oh, and dt. Look, in my original integral, I have replaced x with 1 minus x. I have got the definition of f of 1 minus x. And in my original integral, I applied King's rule. I got the new definition of f of x. Look at f of x after the King's rule. 0 to 1, 1 minus t to the power minus x into t to the power x minus 1. Look at f of 1 minus x. Look at f of 1 minus x, t to the power x minus 1 into 1 minus t to the power minus x from 0 to 1. It's the same. It's the same. F of x is equal to f of 1 minus x. This is the major catch of the question. This is the heart of the question, the soul of the question, the beauty of the question. That very bit which is making this question super duper amazing. You had your original integral, you apply the King's rule, you get another version of f of x. And in your original integral, you replace x with 1 minus x, you get f of 1 minus x. You will realize this f of x and f of 1 minus x are actually identical. And can you replace x with 1 minus x? Yes, you can, because your x is ranging from 0 to 1. And when your x comes from 0 to 1, your 1 minus x also comes from 0 to 1. So your original given integral is true for every x coming from 0 to 1. That means it's also true for 1 minus x, no? Because that is also something which is coming from 0 to 1. So replacing x with 1 minus x is a very valid step. Okay, what am I getting? F of x is f of 1 minus x. This is beauty, guys. You have to take a second to appreciate this. You have to take a second to appreciate this, because the moment you get f of x is equals to f of 1 minus x, differentiate both sides. Why? Because you want f dash half. So you are interested in f dash as it is. So f dash x is equal to minus f dash 1 minus x. Is this cool? You want f dash half. So plug in x as half. You get f dash half is equals to minus of f dash 1 minus half, which is half. Twice of f dash half is 0, which means f dash half is 0. Easy peasy lemon squeezy. The question was supremely easy, isn't it? The question was literally supremely easy, provided the catch was clear to you. That is why this question is one of the favorite questions of mine, because here, first of all, in the integrand, there are two variables involved. One is t, one is x, which confuses the students. It definitely confuses students that the integrand is consisting of two variables. But actually here only t is our variable, because it's with respect to t that the integration is happening. The limits are over t, guys. X is kind of behaving like a constant. Okay, right now in the integrand on the right hand side. All right, so King's rule will be applicable on t. After that, replacing x with 1 minus x and then getting the outcome of f of x equal to f of 1 minus x is just fantastic. Okay, I hope you've taken a note of this, because if you get integrand like this or integral like this, you have to proceed in the same manner, and that is why this question becomes one of a kind type of a question which you must note in your notebooks. Alrighty, come to this one. Come to this one, people. Very, very nice question. Something which can give you a good feeling, something which can give you a feel-good factor, as some questions give you, no? That kind of a factor this question can give you. See, it's written one integral, I'll change the color, one integral plus another integral. Take this as I1, take this as I2. Because they both are looking like two different forms, no? So let's not solve them together. Let's solve them separately. Look at I1. 0 to 1, cube root of 2x cube minus 3x square minus x plus 1. Correct? Clearly, this is neither an even function or an odd function. I will 100% apply my King's rule. No doubt about this. When you don't know what to do, go back to the basics, apply King's rule. Whenever you feel you're stuck, you don't know what to do, how to proceed, apply King's rule. 99.99% of the times, it works. Okay? King's rule, replace x with 0 plus 1 minus x. So you are getting I1 is equal to 0 to 1, 2 times 1 minus x whole cube minus 3 times 1 minus x whole square. Here also 1 minus x and then plus 1. Cool? Okay. So I1 happens to be 0 to 1, 2 times a cube plus b cube minus 3a square b plus 3ab square. Okay. Minus 3. A square plus b square minus 2ab minus 1 plus x plus 1 to the power 1 by 3. This gets cancelled. Okay, I1 happens to be 0 to 1, 2 plus 2x cube minus 6x plus 6x square minus 3 minus 3x square. I'm just solving, nothing else. Whole to the power 1 by 3. A cube minus b cube. Yes. Is this cool? Now tell me, you have minus 2x cube, then you have plus 6x square minus 3x square, so plus 3x square. Okay, then you have minus 6x plus 6x 0, so plus x. Okay, then you have 2 minus 3 is minus 1. Yes or no? Yes or no? To the power 1 by 3, and this is the integral 0 to 1. Oh my god. Actually, this is negative of what is I1? This is minus I1, bache. I1 is nothing but minus I1. You can check. I1 is nothing but minus I1. Can you see? Minus 2x cube plus 3x square plus x minus 1. It's negative of what is given in the question in I1. So I1 plus I1 is 0. That means 2I1 is 0, or rather I1 is 0. The moment I1 is 0, I'm going to move on to I2. I2 is integral 0 to a dx upon x plus root over a square minus x square. What do you think? How do you think I should approach this integral? Because this one is a very famous integral which you've seen in indefinite integrals quite a lot of times. And there is a standard substitution which works the best. What is the substitution? Anybody? Anybody? The substitution is take x as a sine theta. Yes or no? Perfect substitution, people. Take x as a sine theta. Yes or no? When x is 0, theta is 0. When x is a, what happens? Sine theta is 1. That means theta is pi by 2. Dx is equal to what? A times cos theta d theta, right? So a times cos theta d theta upon x is what? A sine theta. So a square minus a square sine square. So a times 1 minus sine square is cos square. Under root cos square is cos because we are in 0 to pi by 2 range. It's not mod cos, it is just cos. So a cos. So you get a sine plus a cos. And this is a supremely simple, straightforward standard integral. Please apply your King's rule over here. You will get another I2. You add both of them. The value of your I2 will come out to be pi by 4. Very standard. Very standard, very regular, very simple integral. Just take this I2 after the substitution. Whatever is I2, take that. Apply the King's rule, you will get another I2, add both of them, and you will get the value as pi by 4. So 0 plus pi by 4 gives you pi by 4 as the answer. Easy peasy lemon squeezy. Done? Now come to this question. This is very nice. This is supremely good. And this is going to rack your brain. This will help you sharpen your brain. This will help you polish the concepts very nicely. M is given as minus 2 to 0. N is given as 0 to 2. But one thing very carefully, if you observe, you will realize that the integrand is same. Oh, just realize this. The integrand is same. It's perfectly matching. The integrand is same. It's perfectly matching. No. So what to do? Might as well consider minus 2 to 2. Yes or no? That means I'm asking you to consider m plus n. Minus 2 to 2 mod sine x upon GIF of x by pi plus half dx. Now the concept starts. What is the concept? Do you know that GIF of x plus GIF of minus x is actually equal to 0 when x is an integer? Yes, no? And it is minus 1 when x is not an integer. In place of x, if I plug in x by pi, I will get this plus negative of this is equal to 0 when x by pi is equal to an integer, or x is equal to n pi, where n is an integer. And it will be minus 1 if x is not equal to n pi. N is an integer, remember? Now here, please understand, it's nowhere given that x is some integral multiple of pi. It's nowhere given in the question that x is an integral multiple of pi. Yes or no? In fact, after 0, the first integral multiple of pi is pi, which is 3.14. Or if you come before, it's minus pi, which is minus 3.14. So between minus 2 to 0, actually there is no integral multiple of pi lying. Similarly, between 0 and 2, there is no integral multiple of pi lying. Right? It's 3.14 or minus 3.14. That means clearly it's evident that x is not equal to an integral multiple of pi. If it is not, this is what I'm going to use. This is what I'm going to use. And I'm going to replace GIF of x by pi with minus 1 minus GIF of minus x by pi. Tell me. Please tell me, quickly tell me. Yes? Or understand one more thing. Understand one more thing. Very basic, very obvious. This bache, if you check, mod sin x is even, but the denominator is neither even nor odd. So overall, if I talk about, this is a Nino function. So let's apply the King's rule. What is the harm? M plus n will come out to be minus 2 to 2 mod of sine of minus x. Is minus sine x after mod, it will be same as mod sine x. But here things will change. It will be minus x by pi plus 1 by 2. And now you can replace GIF of minus x by pi with minus 1 minus GIF of x by pi. So what will you get? This was your original equation. This is after applying the King's rule. Okay, fine. This will become equal to minus 2 to 2 mod sine x. Listen to me very carefully. It's supremely important. This is minus 1 minus GIF of x by pi, and already there is a half. Yes? So minus 1 plus half is minus half. Very good, Priyanshu. Minus 1 plus half is minus half. Right? So you get mod sine x upon minus GIF of x by pi minus half. Or you can take out minus common and you will be left with this plus half dx. This minus can come outside, and what is this? Huh? Isn't this negative of the first equation? This is your, let's say I, then this is your minus I, no? Yes, you're correct. If the first equation is your I, then this is your minus I. So I plus I is 0, that means m plus n is 0. I is equal to minus I, so 2i is 0 or I is 0. If you're getting I is 0, that means you're getting m plus n is 0, na? And if m plus n is 0, that means m is equal to minus n. If m plus n is 0, m is equal to minus n, no? Yes, ma'am, no, ma'am. Yes? Is this question clear, bache? Easy? Super easy? Just remember the property GIF of x plus GIF of minus x is 0 when x is an integer, and it is minus 1 when x is not an integer. Come to this question. Very nice. Beautiful question, wonderful question, must do. This question is a must do. And after this, we are jumping on to periodic functions or other periodic properties. Let's start. F of x is given to you and you are being asked what is f of x integral from 0 to 1. Now, I am not a fool to start computing f of x. Why should I? Why should I? Tell me. Instead, I will not be computing f of x with this given definition of f of x. No. Instead, I need 0 to 1 f of x dx. This is my I. Let me apply the King's rule. No. Let me apply the King's rule. My I will become 0 to 1 f of 1 minus x dx. Yes. Now my agenda happens to be to establish some relationship between f of x and f of 1 minus x. Is there even a relationship between, very good Priyanshu, very good. Is there even a relationship between f of x and f of 1 minus x? Huh? F of x and f of 1 minus x, they both are equal, no? F of x integral from 0 to 1 is equal to f of 1 minus x integral from 0 to 1. Is there a relationship between f of x and f of 1 minus x? See, f of x is given to us as x cube minus 3 by 2 x square plus x plus 1 by 4. Yes, you are correct. Replace x with 1 minus x. You will get f of 1 minus x is equal to 1 minus x whole cube minus 3 by 2 into 1 minus x whole square plus 1 minus x plus 1 by 4. Please check. Please check. When you simplify this, you get minus x cube plus 3 by 2x square minus x plus 3 by 4. And if you add f of x plus f of 1 minus x, what will you get? Plus x cube minus x cube 0, minus 3 by 2 x square plus 3 by 2 x square 0, x minus x 0, 1 by 4 plus 3 by 4 is 4 by 4, which is 1. This is the beauty of this question. This is the beauty, bache. This is the beauty. The relationship between f of x and f of 1 minus x is that f of x plus f of 1 minus x is nothing but 1. Is it understood? So my I was integral 0 to 1 f of x dx. Right? This was my I. After applying the King's rule, this came out to be equal to 0 to 1 f of 1 minus x dx. But f of 1 minus x is 1 minus f of x. This becomes 1 minus f of x dx. See, f of 1 minus x is equal to 1 minus f of x. We just proved. F of 1 minus x is 1 minus f of x. What about the next step? See, f of 1 minus x is coming out to be equal to 1 minus f of x. So, f of 1 minus f of x is 1 minus f of x. F of 1, in place of x, replace f of x. So, f of 1 minus f of x is 1 minus f of x. This is 1 minus f of x. Is this clear? So, you get 0 to 1, 1 dx minus 0 to 1 f of x dx, which is nothing but I. Integral from 0 to 1, 1 dx is nothing but 1. So, 1 minus I. I is equal to 1 minus I, that means 2I is equal to 1 or I is equal to half. How many of you all are getting the value of I as half? Are you getting the value of I as half? Yes? Got it? Hashtag HDCC everybody. Is this question clear? Supremely important, guys. Every question that I'm sharing with you is having a different flavor. I don't want you to please live by the principle that practice makes a man perfect. Listen to me. Listen to me carefully. This is a myth. It's not practice which makes a man perfect. It is perfect practice which makes a man perfect. If you want to excel at math, you have to do perfect practice. What is perfect practice? What is perfect practice? If you just solve 200 questions of same type, it is not going to land you anywhere. It's a redundant effort. But if you solve 50 questions covering multiple varieties, that is what will give you the outcome that you desire, that will take you closer to your goal. So solving 200 questions of one type is just massaging your ego and feeling that, okay, yes, I am pro at this. But actually, you are not pro at the chapter, you are just pro at solving that type of a question. Rather solve 50, 60 questions covering multiple varieties. That is what is going to help you. Okay, so it's not practice which makes a man perfect, it is perfect practice which makes a man perfect. That is why today the questions which I'm sharing with you are not of the same type, the same format, the same model. No. Everything has something or the other different. Either the approach is different, the question type is different, the hack to crack the question is different, the trick is different. Rule is the same, the king's rule or even odd property or the queen's property. Of course, the concept is not going anywhere. But how to apply, when to apply, how to think in what direction is something that every question is challenging us to do in a different way or the other. Yes? I'm not going to tell you that where are these questions from. No. Some questions PYQ, some questions not telling you. Some secrets need to be with the teacher. But see, no matter where the questions are from, I'm just kidding, no matter where the questions are from, of course, I'm bringing them here before you after a lot of years of experience and a lot of hard work, definitely, and the relevance of these questions in the next exam. There were many more questions, but those questions have lost their relevance to enter the exam now from 2025 onwards, and that is why they are not being discussed in this live session. So that much hard work a teacher puts in the sessions. Which PYQs to grab, which new questions to grab, which modified questions to grab, and out of that pool of questions, which question is bound to enter in the paper in the upcoming exam, and which one have lost their relevance. Those have to be said bye-bye to. Okay, so no matter where the questions are from, please make sure, guys, you're attending the live every day whenever it's happening on a regular basis, because that is what is going to really help you and polish your concepts from start to finish, making you exam ready. That's what is the agenda, because we are preparing exam oriented. Let's go to the next property, which is the periodic property or the Jack property. What does it say? Jack property, everybody, right in front of you. F is a periodic function with fundamental period t, then integral 0 to n t f of x dx is n times 0 to t f of x dx. Why? Because if a function is periodic with period t, it's but obvious. Just visualize. If a function is periodic with period t, that means after every interval of length t, its behavior is repeating, its shape is repeating, its design is repeating, its values are repeating. So over one interval of length t, whatever is the shape, the design, the form, in every consecutive interval of length t is the same shape, same design, same form, same values. It's ditto photocopy. So if this function is having period t and I want to integrate it from 0 to nt, then because its design is same over every interval of length t, I will rather integrate over just one interval of length t, which is from 0 to t, right? And take that n times. This plus this plus this plus this plus this, the same quantity I am adding with itself n times, which means n times integral from 0 to t. Very obvious property. Very obvious property. Yes? Okay? Thank you. I so remember you, Harry Potter. आपसे attend किए थे, I got 99.22 percentile in math. Thank you. And kudos. Keep working hard. Next is its variation only. From a to a plus t, integral is same as from 0 to t. Why? Because a to a plus t, what is the distance travelled? What is the distance travelled? It is t units. A plus t minus a is t units. And from 0 to t, again the distance is nothing but t units. So integrating a function from a to a plus t is same as integrating it from 0 to t. Why? Because over every interval of length t, its design is the same, its shape is the same. Okay, so you integrate it from 0 to t, which is a much easier manageable interval than from a to a plus t. So the only thing matching is the distance between the lower and the upper limit. Nt to mt, again, what is the distance? What is the distance? M minus n times t is the distance. So it's equivalent to saying that you integrate from 0 to m minus n times t. But m is an integer, n is an integer. So m minus n is also an integer. So using the first property, it will come down. M minus n times integral 0 to t. Is this making sense? Similarly, the last one, a plus nt to b plus nt. What is the distance? B plus nt minus a plus nt. Nt cancels out, b minus a. So 0 to b minus, a to b is the same. A to b, why? Because again the distance is b minus a. Okay, so the moment distance between the upper and the lower limit is the same, you can write them in one form or the other. These are just the alternate forms. But majorly what's important is the first two properties. I'll make you visualize as well. See, quickly visualize this. This is your function having fundamental period as t. That means over every interval of length t, its shape, its design, its graph is the same. So if you want to integrate it from 0 to nt, rather you integrate it over one interval of length t and you add this value with itself n times, which means you multiply n with this one single integral from 0 to t. Basic, supremely basic, right? Similarly, a to a plus t, look here carefully look here, look at this design. This is a plus t. I want to integrate from a to a plus t. That means I'm interested in this area. I'm interested in this shaded portion, guys. A to a plus t. I'm interested in this shaded portion, but because this function is periodic with period t, please realize how much ever is left here, that is what is being covered here. So this part, if I bring here, I'm going to get the same area. From 0 to t, f of x dx is the same. So please remember these properties very nicely. Very, very nicely. These two are supremely important. Cool? Cool? Any problem? Anybody? Any problem? Visualizing, understanding? I don't want you to cram. I never want my kids to cram. Never ever. Can I start? Okay then. Tell me. Quickly tell me. What if I have pi to 10 pi mod sin x? Now please understand, sin x period is 2 pi. Mod sin x, what is the period, guys? Who will tell me what is the period of mod sin x? Who will tell me what is the period of mod sin x? Everyone, quickly. Mod sin x looks like this is 0, this is pi, this is 2 pi. Very good, it's pi. Mod sin x, this is a periodic function with period pi. Correct? And the distance from pi to 10 pi, the distance is 10 pi minus pi is 9 pi. So I can write this as 0 to 9 pi mod sin x. Correct? 0 to 9 pi. Distance, I am interested in the distance. Now because pi is the period, 9 will come down, 0 to pi mod sin x. 0 to 9 pi. Why 9 is able to come down? Because 9 is an integer. Remember, 0 to nt is n times 0 to t when n is an integer. Yes? Very good, very good. 9 times integral 0 to pi. Mod sin x is what? In 0 to pi, mod sin x is same as sin x. Bingo, done. Done, people. This is done. Done. Yes, ma'am. No, ma'am. Yes, ma'am. No, ma'am. Is this cool? Very, very, very good. Okay, so here is a diagram actually of the same. This much you've understood very nicely. Let me show you the diagram. The diagram approach is what is going to help you even visualize. See. From pi to 10 pi, I want to integrate mod sin x. This is mod sin x graph. Now see, instead I will be integrating from 0 to 9 pi. From pi to 10 pi, number of mountains is the same as that from 0 to 9 pi number of mountains. And it's all symmetric mountains. So I will just catch hold of the area of one mountain and multiply 9 times. Yes, 18 is the answer as you all are giving me. Just wanted to make you visualize, so I've shown you with the help of diagram, but I hope the concept is clear. What is this saying? This is saying 0 to 200 pi root over 1 minus cos 2x dx. Guys, tell me, how will you solve this? How will you solve this? 1 minus cos 2 theta. 1 minus cos 2 theta is 2 sine square theta. Whenever you have a very big interval of integration, that is when you apply the periodic property. Right now, you have to integrate from 0 to 200 pi. You are not supposed to do that. You will have to somehow reduce this interval of integration. And how will you do that? By using the periodic properties. Understand how? This will give you integral 0 to 200 pi. Root 2 will come out. You're left with under root sine square x. Under root sine square x is not sine x. Under root sine square is not sine x, bache. It is mod sine x. If you don't write mod, go went gone. Marks are go went gone. Future go went gone. percentile went gone, and one little slap on your face also. Okay? Okay? Don't miss the mod sign. Under root sine square is mod sine x. Now, root 2 is written here. Okay? 0 to 200 pi mod sine x. Guys, the period of mod sine x is pi. So, this is nt only, na? 200 times pi. N is 200, t is pi. So, n will come down. You will be left with 200 root 2 integral 0 to pi mod sine x. But from 0 to pi, mod sine x is same as sine x. And you're done. 0 to pi sine x is 2 units. So, 400 root 2 is the answer. Yes, 400 root 2 is the answer. I just told you from 0 to pi by 2, under the sine curve, the area is 1. From pi by 2 to pi, again it's 1. So, from 0 to pi, it's 1 plus 1, that is 2. Cool, people? Did you understand? Now, what about this one? Who will tell me the answer of this question? Very important, very interesting. Very, 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 very interesting. Who will tell me? I want to integrate from 0 to 20. Now, this is a very big interval of integration. I am not supposed to integrate from 0 to 20 ideally. I have to reduce this interval of integration. And how will I do that? Rama, please tell me. How will I reduce this interval of integration? By using the periodicity of the integrand. But what is the period of e to the power fractional part of x? Tell me. Harry Potter is saying period is 1. Priyanshu is saying 0 say 1 will be the same as 1 say 2. And so on. Tell me, tell me, tell me, tell me, tell me. Harry Potter is absolutely correct. Why? It's written exponential of fractional part of x. Always remember, when you have f of g of x, its period of this, I'll write it like this, period of f of g of x is equal to period of g of x. Will you remember this? If your g is periodic, then f o g, its period is nothing but period of the inner function, which is g. That is why exponential of fractional part, the period will be that as that of the fractional part. And fractional part function's period is 1. The period of this complete integrand is 1, bache. So this is nothing but 20 times 1, na? 20 will come down. 0 to 1 e to the power fractional part of x dx. But you know the graph of fractional part of x. And so on. This is fractional part of x. In 0 to 1, the definition is y equal to x. Yes or no? So this will be 20 times integral 0 to 1 e to the power x dx. Very good, Akshit. Perfect job done. Perfect job done. Okay. So this will give you 20 times e minus 1. Any doubt, anyone? Please stop me right now. Remember, remember, remember. Very important. Very important. Period of FOG is same as period of the inner function g. Come to this one. 0 to 10. GIF of sine 2 pi x. Tell me. GIF of sine 2 pi x. Again, I'm not going to integrate from 0 to 10. I have to reduce this interval of integration to make it easy for me, more manageable for me, more doable for me. For that, I need to use the periodicity of the integrand. Again, this is GIF of sine 2 pi x. See, what is it? GIF of sine 2 pi x. This is like f of g of x. So, period will be that of g. Period will be that of g. What is the period of sine 2 pi x? Tell me. Sine x, the period is 2 pi. Sine ax, the period is 2 pi by mod a. So, sine 2 pi x, the period will be 2 pi upon mod 2 pi, which is 1. The period is 1. So, GIF of this, again the period will be 1. How many of you understood? Very good, Harry Potter. Very good, Priyanshu. Very, very, very good. Fundamental period here is 1, bache. So you are going to get, this is 10 times 1. So 10 times integral 0 to 1 GIF of sine 2 pi x dx. Now the interval of integration has become very small, 0 to 1. How will I integrate? I have already told you. Whenever you have to integrate GIF, please check wherever in my interval of interest, my inner function, inner quantity is becoming an integer. So between 0 and 1, I want sine 2 pi x to become an integer. That means it can become either 0 or 1 or minus 1. That means 2 pi x can become what all angles? 0, pi by 2, pi, 3 pi by 2, minus pi by 2 and so on. That means x will become what? 0, comma, pi by 2, pi cancels out, 1 by 4. This will be 1 by 2. Then there is minus 1 by 4. No, not taking because I want 0 to 1. Then 3 pi by 2. So 3 by 4. Okay. 2 pi. So 1. That's it. That's it. Between 0 and 1, there are these inputs. What are inputs? 0, 1 by 4, 1 by 2, 3 by 4 and 1. So I will break my integral from 0 to 1 by 4, 1 by 4 to 1 by 2, 1 by 2 to 3 by 4, 3 by 4 to 1. Any confusion? Guys, you have to be super interactive. Write hashtag HDCC in the chat, then only I will understand it's absolutely clear to you. Because between 0 and 1, at 1 by 4, 1 by 2, 3 by 4, my inner function is becoming an integer. I will split my integral there, break my integral there. Break it up into piecewise integrals. I will write this as 10 times integral 0 to 1 by 4, 1 by 4 to 1 by 2, 1 by 2 to 3 by 4, 3 by 4 to 1. Now when x is 0, 2 pi x is 0, sine 0, 0. At 1 by 4, what are you getting? Pi by 2, sine pi by 2 is 1. So in 0 to 1 by 4, sine is ranging from 0 to 1. Here the answer will be 0. GIF will be 0. Okay? At 1 by 2, it's ranging from 1 to 0 or 0 to 1. Again, the answer is 0. At 1 by 2, it's 0. At 3 by 4, it's minus 1. So between minus 1 and 0, GIF is minus 1. At 3 by 4, again, it's minus 1. At 1 is equal to 0. So minus 1 and 0, again, the GIF is minus 1. Yes, the answer here will come out to be minus 5. Is this clear, guys? Please tell me. Is this absolutely clear? Bang on clear. Hashtag HDCC. Everybody, quickly tell me. You have to remember before I move ahead. Please remember sine x period is 2 pi. But mod sine x period is pi. Similarly, sine ax period is 2 pi by mod a. Mod sine x period is pi by mod a. You actually end up dividing by half. Okay? Cool? Dividing by half? No. Multiplying by half or dividing by 2. Now, if I say GIF of sine ax, GIF of sine ax, it's the same as that of sine ax, which is 2 pi by mod a. If I tell you fractional part of sine ax, what is the period? That of sine x, which is 2 pi by mod a. But if I ask you sine of fractional part of x, you will say the period is 1. Please note this down. All the periods, guys, all these periods, please note this down. Period of sine, then mod sine. Sine ax, then mod sine x. GIF of sine ax, fractional part of sine ax, and then sine of fractional part of x. How the modification can occur, I don't know, but we should be well versed with every aspect, every different form. Perfect? Cool? Very good. Very good. I hope now you've very nicely understood how to deal with questions based upon periodicity. Let's attack some PYQ, some very nice brainstorming questions which will help you sharpen your knowledge on DI and establish a firm grip upon it. Let's go. F is a function from R to R, continuous, satisfying f of x plus k is n for all x in R, where k is positive, n is a positive integer. I1 is given to you, I2 is given to you. You have to establish a relationship between I1 and I2. Brilliant question, guys. Brilliant question. Anybody who knows how to start? You know, as a matter of fact, that in 2022, math was relatively tougher. Very good. It was really a tough paper in 2022 with respect to the JEE Main exam. And that is why some questions which have come in 2022, which were not super bouncer questions, but they literally required you to think in a certain direction. They were not supremely out of the box. They were from within your concept knowledge only, but the questions were a little bit tweaked in such a way that it was difficult to decode what to do. But after coming out of the examination hall, students were able to decode. And these are the questions which actually hold a chance to get repeated in 2025 in some of the other shift. Yes, 2022 JEE Main paper was difficult, but doesn't mean that every question of 2022 JEE Main is worth leaving. No. There are many questions which were in the doable category. They were just framed in such a way that it was not possible for a student in one shot to decode the approach. And that is why practice in them becomes a compulsion. Tell me. Now here again the question is trying to teach you something very important. You have f of x plus f of x plus k is equal to n for all x real. Whenever you get such an equation, always remember you have to perform replacement. Yes, correct, Harry Potter. Perfect job done. Replace x with x plus k. When you do that, you get f of x plus k plus f of x plus 2k is equal to n. And how is this beneficial? Because now when you subtract, what do you get? F of x plus k minus f of x plus k, n minus n. You're left with f of x minus f of x plus 2k is equal to 0, na bachche? But this immediately means that f of x plus 2k is equal to f of x for every x real, which is the primary definition of a function having period 2k. When f of x is equal to f of x plus t for every x in the domain, then t is said to be the period. Because what does this imply? What does this mean if you read it in English language? What is its interpretation? That whatever is the answer at the input x, same is the answer after you travel 2k distance, which is x plus 2k. Whatever is the output at x, same is the output at x plus 2k. That means same is the output that you obtain when you travel 2k distance, before or after, wherever. So after every 2k distance, the output is repeating. That means whatever is the graph of the function over one interval of length 2k, same exact photocopy ditto is the graph of the function over every consecutive interval of length 2k. This function is periodic with period 2k. Very good. The period of the function is 2k. And now it's very simple for me to compute the integrals. Now it's a cakewalk. 0 to 4nk f of x dx. Guys, understand? 2k is the period. So 2k is the period and 2n. N is an integer, 2n will be an integer. Correct? So 2n comes down, 0 to 2k f of x dx. Cool? Only till here I can solve I1. Yes, Priyanshu, yes, Harry Potter, perfect. Let's go to I2. Minus k to 3k f of x dx. What will you do to change your limits from 0 to something? You are not liking minus k to 3k. No, your favorable situation would have been 0 to something. So how will you manipulate your integrand? What are the substitutions you will use? How exactly? Not directly, no. Not directly, na, Priyanshu. If you replace x with t minus k, your dx will be same as dt. But your x is minus k plus k, t will be 0. And 3k plus k, t will be 4k. So you are right, limits is going to change from 0 to 4k, but as a result, integrand will also change. This will be t minus k and here is dt. Oh, okay. Well, dummy variable first of all, 0 to 4k f of x minus k dx. Okay, what next? What next? How to write this in a proper form? I don't like f of x minus k. I need f of x. I don't like f of x minus k. No, no. What will I do? I will use my relation again. No, I am given f of x plus f of x plus k is equal to n. So if I replace x with x minus k, I will get f of x minus k plus f of x is equal to n. That means f of x minus k, bachche, is nothing but n minus f of x. Yes, you are correct. Yes, you are correct. This is the tricky part. This is the tricky part. F of x minus k is nothing but n minus f of x dx from 0 to 4k. And now things are very simple. This is 0 to 4k n dx minus 0 to 4k f of x dx. Now you can apply again your periodicity principle, the periodic property, Jack property. 2k is the period. So 2 times 2k. 2 times 2k, 2 will come down 0 to 2k. Yes, but 0 to 2k, look here, please look here. 0 to 2k f of x dx is I1 upon 2n. Yes or no? Hi Rushabh, how are you? So good to see you. Literally, super good to see you after so long. I2 is equal to integral n 4k. Correct? That's it. That's it. Minus 2 times I1 by 2n. Yes, ma'am. No, ma'am. So I2 is equal to 4nk minus I1 by n. Is this something that you are getting? Is this something that you are getting? Which means n times I2 plus I1 is equal to 4n square k. Yes, ma'am. No, ma'am. Superb question solved. Superb question solved. This question is one of a kind. One of a kind. Ni2 plus I1 is 4n square k. Is every step, every minute detail clear to you? This is not something which all students are able to solve, let me tell you. If I'm making you practice this, there is a reason behind it, there is analysis behind it, there is logic behind it, and there is a great deal of vision behind it. Okay, is every step understood? The very first takeaway here is this. This equation, whenever you see, it is shouting at the top of its voice, periodicity, periodicity, periodicity. Replace x with x plus k and bingo, you get 2k as the period. All right. Can you show that one what? What are you saying? This or this? Please check if everything is visible. I'll move aside. Cool? Okay. Let's go to the next question now. This is one of the most fantastic questions which has been framed in the history of JEE Main, based upon periodic property. Because look at the framing, look at the design, look at the language, look at the concepts involved. My God, it's such a beautiful question. Like the one who framed it itself means wow, like wow. Just read it. Just read it. F is a real valued function defined on an interval minus 10 to 10 using this definition. What is the value of pi square by 10 minus 10 to 10 f of x into cos pi x dx? Brilliant, brilliant questions. Change of limit A is the answer. I don't want you to tell me a crammed answer. Rather, I would be supremely happy if you tell me the approach. This was a very old advanced PYQ. Do you know that? This was asked in JEE Advanced, I guess 2010 or 2009, and then it got repeated in JEE Main 2022. This is what I'm saying. Very old advanced questions are repeating in JEE Main. This is a clear signal. This is happening many times. It's a clear signal that, guys, old advanced PYQs which are relevant for your JEE Main, you have to practice that. And that is exactly what I'm cherry picking and bringing in your sessions. I'm not bringing random collection of questions. I'm actually bringing cherry picked, selectively picked questions, some advanced level, very old, some JEE Main level, and some really new, nice, modified, tweaked questions. Great practice. Okay. Can you tell me the approach? Yes, you are correct. Pyramid, pyramid, pyramid. Why? Because look here. People who have not solved this before, if you have, great. If you have not, please understand this. F of x. This is x minus GIF of x. If GIF of x is odd, and it is 1 plus GIF of x minus x if GIF of x is even. First of all, tell me, x minus GIF of x is nothing but fractional part of x, right? This is fractional part of x when GIF of x is odd. And this is 1 plus, or rather 1 minus fractional part of x when GIF of x is even. Yes or no? Because what is this? This is 1 minus fractional part of x plus x. Or rather you can write it like this. No, this is 1 plus fractional part of x minus x. So 1 minus x minus fractional part, GIF of x. So 1 minus x plus GIF of x. So x minus GIF of x is fractional part of x. So 1 minus fractional part of x. Is this clear? Now let's start. Now is the main fun. Now is the main game. How will you proceed? When x is lying between 0 and 1, you know when we're talking about GIF, we have to talk about 1 unit interval sandwiched between two consecutive integers. 0 to 1, 1 to 2, 2 to 3, 3 to 4 and so on. Minus 1 to 0, minus 2 to minus 1, minus 3 to minus 2 and so on. Whenever we are talking about GIF, this is exactly what we talk about. So 0 to 1, GIF is 0. 0 is even. It's even. Yes or no? Yes or no? So what will you get? When you are between 0 and 1, GIF of x is 0. 0 is even. So I'm going to take the definition from here. So when x is between 0 and 1, fractional part of x is x. So you will get 1 minus x. When x is between 1 and 2, GIF of x is 1. 1 is odd. 1 is odd. So you will take the definition from here. Between 1 and 2, what is the definition of fractional part of x? It is x minus 1. When x is between 2 and 3, GIF of x is 2. 2 is even. Come here. If 2 is even, GIF of x is 2. So you will get 1 plus 2 minus x. 3 minus x. Then x minus 3 and so on. When x is between minus 1 and 0, the GIF of x is minus 1. Minus 1 is odd. Minus 1 is odd. So x plus 1. And so on. This is actually the definition of f. And when you start plotting the graph of this function, you know what will you get? So interesting, yeah. This is so interesting. So pretty, beautiful. Can't tell you. From 0 to 1, 1 to 2, 2 to 3, 3 to 4. Getting it? This is what is going to keep on continuing. Similarly on the left hand side. 0, 1, 2, 3, 4, 5, 6, minus 1, minus 2, minus 3 and so on. This is your f of x, bache. And there are two things which are very good, Priyanshu. There are two things which are out loud clear about f. What are those two things? What are those two things which are out loud clear about f? Number one, that it is even function. Can you see it is symmetric with respect to the y-axis? Whatever is the graph on the right of the y-axis, its mirror image is the graph on the left of the y-axis. And secondly, it is a periodic function, guys. It's a periodic function with period 2 units. Can you see that? Whatever is the graph over one interval of length 2, exact same ditto photocopy is the graph over every consecutive interval of length 2. Isn't this amazing? Very good. Did you see that? Just a matter of observation. And this is where the beauty lies. I mean, at this point, I think all of us should have a big smile on our faces. Such a pretty function, man. Like, look at the original definition, x minus GIF of x, 1 plus GIF of x minus x. But when you actually resolve it, you realize it's a stack of, not a stack, but it's a row of mountains. Huh? It's an even function, it's a periodic function. Yes? Now, if I have to integrate, listen to me carefully. You wish to integrate from minus 10 to 10, pi square by 10. Okay, pi square by 10 minus 10 to 10 f of x into cos pi x dx. Listen to me very carefully now. This is where the main heart of the question lies. Why? Because what happens? F is now proven to be an even function. Cos is already even. Product of two even functions is even. So as a result, I'm going to get pi square by 10, 2 times integral 0 to 10 f of x into cos pi x dx. One more thing. The period of f is 2. The period of cos pi x is what? 2 pi upon pi, which is again 2. So period of the pointwise product function will be what? If you know the period of f, you know the period of g, then period of f plus g, f minus g, f into g, f upon g is the LCM of both the periods if it exists. It is the LCM of both the periods if it exists. LCM of 2 and 2 is again 2. That means period of this combined function f of x into cos pi x. This combined function's period is equal to 2. This combined function's period is equal to its LCM of t1 and t2, which is 2. Okay, agreed? Now I will get 2 1s are 2, 2 5s are 10. So pi square by 5 integral 0 to 10 f of x cos pi x dx. But 10 I can write as 5 into 2. 2 is the period, 5 is an integer. 5 can come down. I will get pi square by 5. 5 times 0 to 2 f of x cos pi x dx. This gets cancelled out. Isn't this brilliant? So many concepts have simultaneously gotten used in just one single page of explanation. Isn't this mind-boggling? I mean, I love this question. I always fall for this question every time I solve it. Like I solved it first time in 2022, then 2023, then 2024, and now for 2025 we are solving. I mean, such an amazing question, man. Yes or no? Okay, pi square. We've raved about it enough. Let's now solve. 0 to 1, 1 to 2. Why am I interested in breaking my integral at 1? Because you can check in the graph, 0 to 1 the definition is 1 minus x. 1 to 2 the definition is x minus 1. Because the function is behaving in two distinct manners, that is why the 0 to 2 integral will be broken as 0 to 1 and then 1 to 2. Correct? 0 to 1 and then 1 to 2. Yes. Okay. Now 0 to 1, as I said, is 1 minus x and then x minus 1. So 1 minus x into cos pi x dx and then x minus 1 into cos pi x dx. What will you do now? Now I'll tell you a shortcut. Listen to me carefully. I'll tell you a shortcut which is very difficult for you to come up with during the exam in that pressure situation. But right now, if you are relaxed, you're listening to me carefully, you will be able to understand it very nicely and you will be able to cement it in your memory for long. Here in this integral, take 1 minus x as t. So minus dx will be dt. Your integral will become equal to what? Your integral will become equal to, when x is 0, t is 1. When x is 1, t is 0. 1 minus x is t and cos pi into x is 1 minus t. And this is minus dt. Cos of pi minus theta, what is that? It is cos theta along with a minus sign. Yes or no? Cos theta along with a minus sign. Yes ma'am, no ma'am. Cos of pi minus theta is what? It is cos theta, but pi minus theta lies in the second quadrant. In the second quadrant, cos is negative. So minus cos theta. So minus cos pi t. Minus cos pi t and dx is minus dt. Using one of the minus signs, I will interchange my limits. This will become 0 to 1 t cos pi t dt along with a minus sign. What about the next integral? Please listen to me carefully. Here, take x minus 1 as t. Here we took 1 minus x as t. Here you take x minus 1 as t. What will you get? Dx is equal to dt. As a result, this becomes what? When x is 1, this is 0. When this is 2, this is 1. X minus 1 is t. Cos of pi times, what is x? T plus 1. So you will get cos of pi plus pi t. Third quadrant. Again minus cos pi t. This is minus cos pi t into dt. So what are you getting? Same integral here, no. So your answer comes out to be pi square times, carefully, okay. Your answer comes out to be pi square times minus 2 times integral 0 to 1 t times cos pi t. And this was the major catch. This was the major catch. Why? Because the moment you realize both integrals are actually narrowing down or boiling down to the same integral, you only need to solve one integral, no? Right now it looks like you have to solve two different integrals, but actually you have to solve just one integral. Yes? Yes or no? So minus 2 pi square comes out common. Inside, let's apply the by parts. Oh yes. Let's apply by parts. ILATE, first function, second function. First function, integration of second. So sine pi t upon pi, limits from 0 to 1, minus integration of, differentiation of first into integration of second, sine pi t upon pi, and this is dt. When you plug in 1, you will get sine pi, which is 0, plug in 0, this is 0. So this part completely happens to be 0. Now this minus and this minus will become plus, so you will get 2 pi square, and inside you have 1 upon pi as it is, sine pi t integration, which will give you minus cos pi t upon pi, limits are from 0 to 1. So 1 pi cancels out, minus 2 pi. And another pi is outside here, so this also gets cancelled out. Now cos pi minus cos 0. So this is minus 1 is minus 2, minus 2 into minus 2 is 4. Is 4 your answer, guys? Please check. I am getting 4 as the answer. Is 4 your answer? Quick. Yes, a lengthy question. Yes, the question should not do in round 1. Definitely. But this is certainly a question which you must practice if you are really geared up to ace your JEE Main 2025. It is a must solve, guys. It's a must solve. Number 1, because of the volume of concepts involved. Number 2, because of the trick or the shortcut involved where you narrow down 2 integrals to just 1. And number 3, to appreciate the beauty. Look at the category of question. Look at the design of the question. It's beautiful. Shreya is saying 4. Yes, 4 is the answer. Option A, I guess, was 4. And bingo. A is absolutely correct. Shall we move ahead? Let's go. Tell me, what is the value of this integral? Again, an integral which is shouting at the top of its voice, periodicity. Why is it shouting? Because I'm not interested to integrate from minus 3 to 101. No. Not doing that. Not doing that at all, because the interval of integration is super huge. Why would I do that redundant hard work? I would rather shorten my interval of integration by using the concept of periodicity. So here, please tell me, it's a very interesting question. This is minus 3 to 101, or I can write it from 0 to 104. It's the same thing because the length of the interval is the same. I'm going to write this as GIF of sine pi x dx plus integral 0 to 104 e to the power GIF of cos 2 pi x dx. Guys, very important question, must solve. Let's see who among all of you is able to crack it the fastest. Hi Kayal. Let me see who out of all of you is able to crack it the fastest. First of all, the first step is to decode the period of the integrand. I've already told you. Composition, f of g What is the period? The period of the inner function, which is period of g. So sine pi x, GIF of sine pi x. What is the period? That of sine pi x, which is 2 pi upon pi, which is 2. What about this? Exponential of GIF of 2 pi x, isn't it? Exponential of GIF of cos 2 pi x. Always go to the innermost function, cos 2 pi x. What is the period? 2 pi upon 2 pi, 1. 1 is the period. Very good. That means this has period equal to 1. Anybody, any confusion? If the period you don't know how to compute, the question further cannot be solved by you for sure. It cannot be solved by you. 100%. Very good. Okay. Is this cool? So let me take this integral as I1. Let me take this integral as I2. I will solve both the integrals. Okay. So I1, this is 0 to 104 GIF of sine pi x. But 104 is 2 times 52. 2 is the period, no? So 52 will come down. 52, 0 to 2 GIF of sine pi x. Wow. Wow. Now I know how to solve. Now I know how to solve. Why? Because I just need to catch hold of those values of x between 0 and 2 where my inner function sine pi x is becoming an integer. Very good. Where all will I split? Where all will I split, Priyanshu, Shreya, Kayal? Tell me. Maya, tell me. Quickly. Tell me. Very good. No, Priyanshu. Not 0 to 1 and 1 to 2. Don't do this. Don't do this blunder. It's not a mistake. It's not even a blunder. It's a crime. Don't do this. I have always told you, today to in this session I've told you I guess 20 times, wherever your inner function is becoming an integer, at those values of x you break your integral. So sine pi x can become an integer either 0 or 1 or minus 1. That's all the integral values a sine function can produce. So pi x, the angle can be 0, pi by 2, pi, 3 pi by 2, 2 pi, and so on. That means x can be 0, 1 by 2, 1, 3 by 2, 2. That's it. I want to integrate from 0 to 2. No. So I only need between 0 and 2. And I have got those values. I will split it up into 0 to half, half to 1, 1 to 3 by 2, and 3 by 2 to 2. That's it. This is how I will be splitting. So my answer will be 52 times integral 0 to half plus half to 1 plus 1 to 3 by 2 plus 3 by 2 to 2. Any confusion, Priyanshu? I guess you're confused. Please tell me, is this clear? How do we integrate a GIF function? Whatever is sitting inside the GIF function, the inner function inside the bracket, that, where is that becoming an integer in my given interval? My interval is 0 to 2. So I need those values of x. And these are x limits. No, limits of x. No. So I want those values of x where my inner function is becoming an integer. It's becoming at half, 1, 3 by 2. So 0 to half, half to 1, 1 to 3 by 2, 3 by 2 to 2. Cool? Now 0 to half, tell me. When x is 0, sine pi x is 0. When x is half, sine pi x is 1. Because it's sine pi by 2, which is 1. That means as x ranges from 0 to half, sine pi x ranges from 0 to 1. So GIF is going to come out to be 0. Perfect. When x is half, it's 1. When x is 1, it's 0. Again, 0 to 1, GIF is going to be 0. When x is 1, 0, 3 by 2, it's minus 1. Minus 1 to 0, GIF is minus 1. Perfect. At 3 by 2, it's minus 1. At 2, it's 0. Minus 1 to 0, GIF is minus 1. Okay? Cool? Can you solve this and tell me the answer? Till the time I'll solve I2. Integral 0 to 104 e to the power GIF of cos 2 pi x. I just explained to you its period is 1. So into 1. 104 will come down very comfortably. 0 to 1 e to the power GIF of cos 2 pi x. Again, the same thing. Yes, very good. 52 by E. Again, the same thing, guys. Wherever the inner function sitting inside GIF is becoming an integer, at all those points, you will break your integral, split your integral. So let's see. Cos 2 pi x can be 0 or 1 or minus 1. So 2 pi x, the angle can be 0, pi by 2, pi, 3 pi by 2, 2 pi, and so on. So x can be 0 upon 2 pi 0. This is 1 upon 4, then 1 upon 2, then 3 upon 4, then 1. So, and I stop at 1. Very good, Priyanshu. This is correct. 0, 1 by 4, 1 by 2, 3 by 4, 1. बच्चे 5 by 4, 7 by 4 नहीं ना, because 5 by 4, 7 by 4 are greater than 1. I only need in the interval 0 to 1. Previously, I needed in the interval 0 to 2. This time, I need in the interval 0 to 1. So, between 0 to 1, these are your values. And accordingly, I'll break. So, 104 integral 0 to 1 by 4 plus 1 by 4 to 1 by 2 plus 1 by 2 to 3 by 4 plus 3 by 4 to 1. Ma'am, I did for 0 to 2. Don't do it for 0 to 2, no, because here the period is 1. So, I'm writing my upper limit as 104 times 1. 1 is my period, 104 is integer, 104 comes down. You're left with 0 to 1 integral. So, don't compute for 0 to 2. That's a blunder. 0 to 1 only. Within 0 to 1, I have 1 by 4, 1 by 2 and 3 by 4. That's it. So, I'll split it up into 4 integrals. Okay? 1 is 0 to 1 by 4, then 1 by 4 to 1 by 2, 1 by 2 to 3 by 4, 3 by 4 to 1. Thumbs up? Thumbs up? Now, when x is 0, cos 0 is 1. Right? When x is 1 by 4, cos pi by 2 is 0. So, inner function is ranging from 0 to 1. GIF will be 0. You will get e to the power 0. Oh. When x is 1 by 4, it's cos pi by 2, which is 0. When it's 1 by 2, it's cos pi, which is minus 1. So, minus 1 to 0. GIF is minus 1. E to the power minus 1 dx. Oh. Then at 1 by 2, it's cos pi, which is minus 1. At 3 by 4, it's 3 pi by 2. At 3 by 2, again, it's 0. So, minus 1 to 0, again, minus 1. So, e to the power minus 1. Now, it's e to the power GIF. At 3 by 4, it's again 0. At 1, it's 1. So, 0 to 1, this is e to the power 0. Please see if there is any confusion, any doubt at any step. Please check. This will come out to be 52 minus 52 by E, or rather, yes. And I guess this comes out to be minus 52. So when you add minus 52 plus 52 cancels out, and your answer, final answer comes out to be 52 by E. Can you calculate this by yourself? This much I think you can calculate. I1 was not 52 by E, Priyanshu. Kaam chori ho rahi hai. I1 was not 52 by E. The final answer is 52 by E. Don't do this. Calculate I1, calculate I2. When you will add both of them, you will get 52 by E. Okay? Cool? Perfecto. Shall we move ahead? Is this question clear? How to deal with periodic functions, how to change the limit by calculating the distance between upper and lower, how to compute the period of a composite function. Everything clear? How to break the GIF function or integral of a GIF function and then calculate the answer. Is everything absolutely clear? Hashtag HDCC till here, guys. Hashtag HDCC till here. Come to this question now. Now, this question again is going to highlight a very important concept of periodicity. Now, here I have to integrate from 0 to 20 pi. Can you tell me what is the period of mod sin x plus mod cos x? Period is equal to what? Can you tell me the fundamental period I'm asking? Fundamental period I'm asking. Now what students tell me is, I'll tell you what students tell me. Students say, ma'am, if f has period t1, g has period t2, then f plus g, f minus g, f into g, f upon g has period LCM of t1 and t2 if it exists. Here I have the sum of two functions. I know the period of mod sine x is pi. I know the period of mod cos x is also pi. So period of mod sine plus mod cos will be equal to LCM of pi and pi, which is pi. Correct. Correct. Pi is the period, but pi is not the fundamental period. The fundamental period, yes, is pi by 2. And you can check that as well. You can check that as well. How to check? How to check? Replace x with x plus pi by 2. Sine of x plus pi by 2 or sine of 90 plus x. Sine of 90 plus x. Tell me. Minus cos x, mod will give you mod cos x. Here also x replaced with x plus pi by 2, you will get mod sine x. It's the same. Whatever is f of x, same is f of x plus pi by 2, no? Yes or no? This means pi by 2 is a much smaller quantity than pi, at which function is repeating its value. After pi distance, it is repeating its value. But before that, after pi by 2 only, it is repeating its value. So fundamental period happens to be pi by 2, bache. Fundamental period happens to be pi by 2. Pi is the period. Any integral multiple of pi by 2 will be a period. That's true, but fundamental period is pi by 2. In fact, please remember this. Please remember this. Mod of sine to the power nx plus mod of cos to the power nx. For every natural number n, the period is always pi by 2. I mean fundamental period. So this question was just to explain this beautiful concept to you. Concept about the period of mod sine plus mod cos, or any mod of sine of any power plus mod of cos of any power. Why? Why? Because now you know pi by 2 is the period, right? The period of this function is pi by 2. Yes or no? Please tell me. The period is pi by 2. Is this understood? Can you take sequence and series? Is that a pain point for you people? Tell me. I want some votes for sequence and series one shot. Tell me. Okay. Now this complete function, if mod sine plus mod cos has period pi by 2, its square will also have period pi by 2. So see, because it's a positive function, no. The period is pi by 2. You will get 0 and then pi by 2, 40 times pi by 2. Mod sine plus mod cos whole square. 40 comes down, you're left with 0 to pi by 2, mod sine plus mod cos whole square, which is what? Come on, in 0 to pi by 2, mod sine is sine. In 0 to pi by 2, mod cos is cos. So this is what you get. That means eventually your answer comes out to be 0 to pi by 2, sine square plus cos square, which is 1, plus 2 sine cos, which means sine 2x. That's it. The question is done. The question is done. Easy peasy lemon squeezy. X plus, or rather minus, cos 2x upon 2, limits from 0 to pi by 2. What is the answer? What is the answer? Please check. Quickly. Pi by 2. 2 cancels out, minus 1 by 2. This pi by 2 minus 1 by 2 plus 1 by 2. And then 0 will give you 1. Please check. Yes? Is this question clear, guys? Beautiful concept explained about the period of mod sine plus mod cos, or mod of any power of sine plus mod of any power of cos. Alrighty then, let's move ahead and talk about this function. Here, I want to hold my head like this. Just look at the function. Look at the integral. Look at the expression to be decoded. Forget about how to solve. Just take a second to look at the expression. I mean, how can someone frame such a question? This question feels like it has been framed deliberately to torture the students. Is it yes or no? Yes or no? Just by the look of this question, one thing we can surely conclude and judge that why? Why torture, man? Why torture? Why are you scaring us by giving us such deadly, scary expressions? Yes or no? Yeah. But I always say, don't judge a book by its cover. Don't judge a book by its cover. Why? Because this question, trust me, is really simple. How is it simple? Why is it simple? Forget about the mod sitting outside. Take a look at the integral. It's 0 to pi by 2 GIF of x square minus cos x, all of this dx. Okay, this is just GIF of x square. Okay, this is bracket. GIF of x square. Okay, tell me one thing. Tell me one thing which is going to make this question super simple. What is the one thing? Don't you know that GIF of any real number is an integer? This is equal to an integer. Do you know this? GIF of any real quantity is 100% an integer. Yes, it's an integer. Let's call it I, for instance. So my integral boils down to 0 to pi by 2 I minus cos x dx. And actually there is a complete GIF here. Here. Okay. I know as a matter of fact, GIF of anything plus or minus integer is GIF of that thing plus or minus integer. Do you know this property? Are you aware of this property? So here also the same thing is written, no? 0 to pi by 2 minus cos x plus integer whole GIF. This is nothing but GIF of minus cos x plus I separately. 0 to pi by 2 dx. Tell me. Yup. Correct. Hats off. Tell me, is this clear? And I'm going to separate the integral. The question is almost done. 0 to pi by 2 GIF of minus cos x dx plus 0 to pi by 2 I dx. But what was I? GIF of x square. See, now how simple the question has become. Pi by 2, please remember guys, what is pi by 2? In fact, it's root pi by 2. Oh, it's not pi by 2, it's root pi by 2, root pi by 2, root pi by 2, root pi by 2, root pi by 2. This is root of 1.57, which is again 1 point something only. Very close to 1, little bit greater than 1. That means between 0 and 1, I want those values of x where my inner function is an integer. So if I want minus cos x to be an integer like 0, 1, minus 1 and so on, cos x has to be an integer 0, 1, minus 1. So x has to be 0, pi by 2, pi, 3 pi by 2, 2 pi and so on. But I want only between 0 and 1. Only between 0 and 1. What are the values of x? Between 0 and 1. Remember, pi by 2 is 1.57. This is 3.14 and so on. The only value of x which is acceptable between 0 and 1, where my inner function is an integer, is 0. So when you plug in x as 0, you will get minus cos 0, which is minus 1. Bache. So you will get minus 1. 0 to root pi by 2 minus 1 dx. Please tell me if there is any doubt, any confusion. Correct? Here also it's root pi by 2. Next, from 0 to 1 point something. 0 to 1 point something. What will you do? When x is between 0 and 1, x square is between 0 and 1. And when x square is between 0 and 1, and then there is 1 point something. Bhai, understand, no, there is 0 and then there is root pi by 2, which is greater than 1. Correct? So, in 0 and 1 and in 1 to root pi by 2, I'm going to break my integral. Yes or no? 0 to 1, 1 to root pi by 2. Because this is 1 point something something, no. So, when x is between 0 and 1, x square is between 0 and 1. When x square is between 0 and 1, its GIF is 0. But when x is between 1 to 1 point something, its square is also greater than 1 but less than 2. So, GIF is going to be 1. That's it, done. Done. Done, bache, done. This is minus root pi by 2. Okay, plus root pi by 2 minus 1. So, this gets cancelled out. Your answer is minus 1. But you wanted, what did you want? Whatever is the integral's value, you wanted its mod. So, mod of minus 1, 1 is your final answer. Where are you confused? Please tell me, where are you confused exactly? I will explain this question 200 times if you want. Tell me, is it the second integral or the first integral? Top part. Top part means this part? Are you saying this part? Are you saying the cos x minus cos x part? Okay, listen to me carefully. One integral is 0 to root pi by 2 minus cos x. It's GIF. Theek, cool. Now understand. X is something. This is 1 point something, no? Something, I don't know. X is lying between 0 and 1 point something. Right? Remember cos graph? This is 0, this is pi by 2. This is 1.57. Here somewhere will be root pi by 2. Understood? So if x is lying, understand, if x is lying between 0 and root pi by 2, your cos x is lying between, this is 1. Your cos x is lying from here till 1. Right? Right? Let's say this is, okay, this is, let's say, y1. So cos x is lying between y1 and 1. So minus cos x will lie between, tell me, minus 1 and minus y1? Yes or no? If y1 is lying between 0 and 1, understand, no, minus y1 will be somewhere here. Here somewhere is minus y1, here somewhere is minus 1. This is minus y1, this is minus 1. If x is lying between 0 and root pi by 2, cos x is lying between y1 and 1. Minus cos x will lie between minus 1 and minus y1. Yes, so its GIF will be what? If entirely minus cos x is lying between minus 1 and minus y1, what is the GIF? What is the GIF? If something lies between minus 1 and 0, what is the GIF? Minus 1, no. That is why the entire GIF is minus 1, na bachche. Is this approach clear? And if I tell you, let's say 0 to root pi by 2 GIF of x square dx, where all is x square as an integer? Where all is x square an integer? Where is it? At 0, at 1, at 2, at 3 and so on. That means x comes out to be 0, 1, root 2, root 3 and so on. Yes? 0, 1, root 2, root 3 and so on. Remember, no, x square should be an integer. That means x square can be 0, 1, 2, 3 and so on. That means x can be 0, 1, root 2, root 3 and so on. Now this is 1 point something something, which is greater than 1. My x is 0, my x is 1. These are the two acceptable values. This is not, this is not. Between 0 and 1 point something, 1 is lying na, where I will break my integral. Yes or no? That is, I am writing this as 0 to 1 and then 1 to 1 point whatever this is. Okay? Now 0 to 1, GIF of x square is 0. 1 to this, GIF of x square is 1. Cool? No, it's okay. Ask me 10 times, I'll explain 10 times. But it should be clear. My agenda is things should be absolutely clear. Let's come to this question, guys. JEE Main 2021, beautiful question. Can you crack this? See, my mug also says, hang in there. Hang in there. Even if you're tired, hang in there. We're just about to finish. Tell me, how exactly will you crack this question? Any idea? Any idea? 0 to 10, GIF of x, e to the power GIF of x upon e to the power x minus 1. Now the problem here is, this is a very big problem. Very big problem, not a chotu-motu problem, it's a big problem. 0 to 10 is a big interval. Of course, whenever we have had 0 to 10, 0 to 20, we have always wanted to use the concept of periodicity to kind of shorten the interval of integration. But here that's not possible because GIF function is not periodic. GIF is not periodic. If you remember the GIF function, it's a step function. It doesn't repeat its value after any time. After any interval, it does not repeat its value. Yes or no? Yes or no? Correct? Correct? That is why this is not a periodic function. And because it's not periodic, I will have to do the hard work. What is the hard work I'll have to do? I will have to break my entire interval from 0 to 10 into small intervals of 1 unit each. 0 to 1, 1 to 2, 2 to 3 and so on 9 to 10. Because in each of these intervals, my GIF is going to behave differently. Yes, this is the hard work required to crack this question. This question was a lengthy question when it came in 2021, but this was a question which was really simple. Trust me, it's simple. It just requires labor from your side. It's just mechanical, it's laborious. You have to write a lot of steps, but it's really doable. And it requires all from you is the definition of GIF. That's it. That's it. So let's break it. 0 to 1, 1 to 2, 2 to 3, 3 to 4, and so on, 9 to 10. Okay. 0 to 1. GIF of x is 0. 0 into anything is 0. This though will be 0 only. Next, 1 to 2. GIF is 1. E to the power 1 upon e to the power x minus 1. Perfecto. 2 to 3. GIF of x is 2. E to the power 2 upon e to the power x minus 1 dx. GIF of x is 3 in this case. So 3 e to the power 3 upon e to the power x minus 1 dx. Here, this is 9 e to the power 9 upon e to the power x minus 1 dx. Yes, breaking it, broke it. Broke it. What next? Tell me. This to chalo is 0 only. Gone. This is e. E comes out. Integral 1 to 2 e to the power 1 minus x dx. 2e square comes out. Integral 2 to 3 e to the power 1 minus x dx. 3e cube comes out common, 3 to 4 e to the power 1 minus x dx, plus and so on, 9 e to the power 9 integral 9 to 10 e to the power 1 minus x dx. Okay, fine. What is the integral of e to the power 1 minus x? Integral of e to the power 1 minus x dx is e to the power 1 minus x upon minus 1. So, minus of this? Yes or no? E outside e to the power 1 minus x, minus of e to the power 1 minus x and limit from 1 to 2 plus 2e square minus e to the power 1 minus x limit from 2 to 3 plus 3e cube minus e to the power 1 minus x limit from 3 to 4. I'm just saying it's just plain hard work. 9 e to the power 9 minus e to the power 1 minus x limit from 9 to 10. Yes. See, if you can observe the pattern, great. If you can observe the pattern, great. If you can't, then you have to write everything. Write everything. Okay, let's see. Let's rub this. Here I have minus e. Okay, e to the power 1 minus 2, e to the power minus 1 minus e to the power 0. So 1 upon e minus 1. Perfect. Then there is minus 2e square. Yes or no? Here I will get 1 upon e square minus 1 upon e. Okay. Minus 3e cube, 1 upon e cube minus 1 upon e square. See, I am getting the pattern. Minus and so on, 9e to the power 9. 1 upon e to the power 9 minus 1 upon e to the power 8. Yes, did you get this now? Did you get this? So here you will get minus 1 plus e. Then there is plus minus 2 plus 2e. See? Cool? Plus minus 3 plus 3e plus and so on minus 9 plus 9e. Question has almost come to an end. Minus 1, minus 2, minus 3 and so on minus 9. Then there is e common 1 plus 2 plus and so on till 9. From here also minus common, you will get 1 plus 2 plus 3 plus 4 until 9. So minus common, sum of first 9 natural numbers is n plus 1 by 2 plus e into n plus 1 by 2. Please check. This is minus 45 plus 45e. Such a nice question. I mean, wasn't it like we're playing a game or something? Because every integral was giving us a familiar pattern. First step, second step, third step, fourth step, fifth step, sixth step, seventh step, all are actually a result of pattern. If you have observed the pattern in the first 1 or 2 steps, it's not mandatory for you to write each and every term. You can just write 1 or 2 terms and then conclude the answer. But I was writing because I was teaching you and I didn't want you to get confused. But here in such questions, yes, they are lengthy. But once you are focusing on them a lot and you are able to foresee the pattern, then you can save your time, save a lot of your time on writing so many steps. Very good. Very, very, very good. It's a brilliant job done. Brilliant job done. Okay, let's go to this question now. Yes. Okay. What is this? Who will tell me? Who will tell me how to crack this question? How to crack this question? Come on. How? What do you think? Come on. Come on, come on, come on. Minus a to a, mod x plus mod x minus 2 is 22. What is minus a to a? X plus GIF of x. It's a brilliant question. You know why? Because when you talk about mod x plus mod x minus 2, what do? No, Priyanshu. Look at the integrand. Let's say this is f of x, okay? Look at the integrand. My f of x is mod x plus mod x minus 2. I know the critical points are 0 and 2. So I'm going to break it up as x less than 0, x lying between 0 and 2, and x greater than 2. When x is less than 0, what do you get? Minus x. Yes or no? And 2 minus x. Oh, okay. 2 minus 2x. Perfect. When x is between 0 and 2, this is x and this is 2 minus x. Minus x plus x cancels out. This is 2. And here x plus x minus 2. So 2x minus 2. Yes or no? Yes or no? So if I plot f, See what I'm doing? I'm going to play smart. I'm going to plot f. I'm going to plot f, okay? Plotting f from minus a to a, and a is greater than 2. So this is 0. Here somewhere is 2. Here somewhere, let's say, is a. That means here somewhere is minus a. Okay? At 0, what is the value? 2. Okay. From 0 to 2, the value is 2 only. Acha, acha. After 2, it is 2x minus 2. And before 0, it is 2 minus 2x. Please check. This is 2 minus 2x. This is obviously 2, and this is 2 plus 2x. No, 2x minus 2. Okay? But I want it from minus a to a. I want it from minus a to a. Okay, minus a is here and a is here. Perfecto. Perfecto. What do I want? This is the graph of f. I want minus a to a integral of f. What is that? Obviously, it is this much portion plus, let me make a line here also, this much portion plus this much portion. Can I say this? It's area number 1 plus area number 2 plus area number 3. Can I say this? Yes, area under curve. This wala integral, which is given to be 22, is nothing but area under this curve, which is area of 3 regions. First is a trapezium, second is a square, third is a trapezium. So what is 22? Guys, what is 22? 22 is area of the first trapezium, which is half sum of parallel sides. So this parallel side to chalo is of 2 units. What about this lamba parallel side, this long one? Plug in x as minus a, you will get 2 plus 2a. Half into sum of parallel sides into height. Height is what? A units. Yes, a greater than 2 is of major importance. Otherwise, how you would have plotted a, how you would have gotten this figure? You wouldn't have. Okay, half into sum of parallel sides into height plus what is the area of this region? 2 length, 2 breadth, side square, 2 square. Plus again half into sum of parallel sides 2 plus plug in a, 2a minus 2 into height is a minus 2. Please check. Please check what is the height. Half into sum of parallel sides into height. This is 22. If you solve this, can somebody solve right now and tell me what is the answer? Because when you will solve, you will get one equation in just one single variable a, which is very simple. After that, it's very simple to compute a. What do you think is the value of a coming out to be? Come on. What do you think is the value coming out to be? Guys, keep hitting the like button if you like this session. If you feel you're learning, do not shy away from hitting the like button. Come on. Does that make sense? That doesn't make sense. No. No, Priyanshu, please check. Please check. What is a coming out to be? From here to chalo 2 gets cancelled out. Tell me. Yes, a is coming out to be 3. Bingo. The moment a has come out to be 3, now your task is minus 3 to 3 x plus GIF of x dx. Please understand, you will write this as minus 3 to 3 x dx plus minus 3 to 3 GIF of x dx. Bache, minus a to a. X is an odd function. Yes, this is an odd function. So this complete integral will have answer 0, no? It's 0. Yes or no? It is 0. You are only left with minus 3 to 3 GIF of x dx. And you know how to solve this, come on. You know how to solve this. This is minus 3 to minus 2, minus 2 to minus 1, minus 1 to 0, 0 to 1, 1 to 2, 2 to 3. Because at all these integral points between minus 3 and 3, my GIF breaks. My GIF breaks. Now it's super easy. So minus 3 to minus 2, this is minus 3. This is minus 2. This is minus 1. This is 0. This is 1. And this is 2. Okay? So you get minus 3. Then minus 2 plus 3 will give you 1. Minus 2, again 1. Minus 1, again 1. Then this is to 0. Plus 1, again 1. Plus 2, again 1. So minus 5 minus 1, minus 6 plus 3. This gives you minus 3 as the answer. No. 2 plus 1, 3. 3 minus 1, 2 minus 2, 0. Yeah, minus 3. What is it? Please check, it's minus 3 or minus 2. Minus 3 minus 2 minus 5 minus 6 plus 1 minus 5 plus 2 is minus 3. One plus 2 is 3. This is 0. Please check. It's minus 3. Calculation mistakes. Don't do it. Minus 3, minus 2 plus 3 is 1, minus 1 plus 2 is 1, 0 plus 1 is 1, 1 minus 0, 2 minus 1, 3 minus 2. Please check, guys. Is it minus 3 or minus 2? Quick, quick, quick. Come on. That's just being human, Priyanshu. It's okay. Sometimes it's okay. Be human. Tell me. Quick, I'm waiting for people to tell me, is this the right answer? Yes? Is this cool? Is the approach clear? Very important category. Very, very important category. If the figure you've drawn correct, you can sail through the question. You can sail through the question. Let's go ahead and talk about this. What is this? Supremely important concept, which is the Leibniz rule or the Leibniz theorem. Oh my God. NTA is crazy after this theorem. Again and again and again and again and again, they've asked questions from Leibniz. And let me tell you, this is a super easy concept, number one. Number two, the questions where it is supposed to be applied, it's very easy to decode. And that is why there is a limited bank of questions which you must practice, which you can practice to ace this topic. Limited bank of questions, limited bank of questions. Very limited. Let's start. Everyone ready for Leibniz theorem? Let's go. Whenever you wish to differentiate an integral with at least one limit as the variable limit, then you use Leibniz rule. What did I say? When you wish to differentiate an integral with at least one limit as variable limit, then you use Leibniz theorem. See, d by dx of integral g of x to h of x f of t dt. What did I do? What did I do? This is my integrand. These are my limits. This is my upper limit. This is my lower limit. Both my limits are functions of x. Okay? And with respect to that same x, I am differentiating. So I'm differentiating an integral whose at least one limit is x, a function of x. That is when I will use my Leibniz rule. It will say integrand of upper limit into dash of upper limit minus integrand of lower limit into dash of lower limit. integrand of upper limit into derivative of upper limit minus integrand of lower limit into derivative of lower limit. Is this clear? Is this clear? This is it. This is it. This is it. That is it. This is what is the Leibniz theorem. Let's attack the questions now and you will be able to ace the theorem within no time. JEE Main 2022, look at the question, guys. Clearly, this is integral where one of the limits is a variable limit. If I wish to differentiate, I will be using my Leibniz theorem. Let's go. Let's go. I want f dash 1 by root 3. I have to differentiate. I have to differentiate. So let's start. Let's start. I have integral cos x to 1 t square f of t dt. Guys, very simple concept. Just focus on the questions and you will be done. This is cos x. Please differentiate both sides. Please differentiate both sides. Can I start? Tell me quickly. Can I start? What do you need? You need f dash 1 by 3. 1 by root 3, f dash 1 by root 3. What do you think I should do? I should differentiate. Ideally, I should differentiate. Differentiate both sides. Okay? What will happen? Integrand of upper limit into upper limit dash. Dash of 1 is 0 minus integrand of lower limit. So cos square x, f of cos x into dash of cos x is minus sin x. Perfecto. Equal to 3 sin square x into cos x and then minus sin x. I have just differentiated both sides. Just differentiate both sides. Now listen to me carefully. This minus cancels out. I want, what do I want? I want f dash 1 by root 3. So basically I wish to isolate f. Once I isolate my f, then I will be able to compute f dash of anything. So what is unnecessary? Unnecessary is cos square x, unnecessary is sin x. So divide both sides by sin x into cos square x. I will have f of cos x equal to 3 sin square cos upon sin cos square minus sin upon sin cos square. So 1 cos cancels, 1 sin cancels, this also cancels. So 3 times tan x minus sec square x. This is your f of cos x. Guys, any confusion till here? Please tell me. I'll write this step again. F of cos x is equal to, this is 3 tan x minus sec square x. Please solve with me. No, ma'am? Yes, ma'am. 3 tan x minus sec square x. What next? Tell me quickly. Tell me. Now I want f dash of something. Differentiate f dash of cos x into minus sin x is equals to 3 times sec square x minus 2 sec x into tan x. What next? Tell me quickly, tell me. No, I want f dash of something. Now this is unnecessary. No, this is unnecessary. I will get f dash cos x divided by minus sin x. So minus 3 times sec square x upon sin x plus 2 sec square x tan x upon sin x. Yes, ma'am? No, ma'am? Now tan is sin upon cos. So sin x upon cos x. This sign cancels out. What do I need? What do I need? What do I need and what should I do? Tell me no. What do I need? What should I do? I want 1 by root 3 f dash 1 by root 3. Remember, if I am at this step interested in computing f dash 1 by root 3, that means I am interested in plugging in cos x as 1 by root 3. Right? Then only I will get f dash 1 by root 3. Na? But I want 1 by root 3 again as a scalar multiple also. So might as well, this means multiply followed by cos x. Multiply by cos x. Yes, this will give me cos x, f dash cos x. Perfect. Perfect setup, because now I can directly plug in cos x as 1 by root 3. I will get 1 by root 3 f dash 1 by root 3, which is exactly what I need. This is equal to minus 3 times sec square x into cos x upon sin x plus 2 times sec square x into cos x upon cos x. This cos cancels out. Sec is 1 upon cos square. So 1 cos cancels out. 1 upon cos gives you sec. So only sec remains. Please check this, which means minus 3 upon sin cos. I'm doing nothing. I'm just converting everything into sin cos. Yes. Now at this stage, you can plug in cos x as 1 by root 3. Plug in cos x as 1 by root 3. You will get 1 by root 3 f dash 1 by root 3, which is exactly what I need. And you have minus 3 upon, what is sine? See, look here. Curly brown hair, 1 by root 3. This will be root 2. This is x. So some people have root 2 by root 3. Sin x will be root 2 by root 3. Cos is 1 by root 3. Correct? Plus 2 sec square x. Sec is what? Root 3. If cos is 1 by root 3, sec is root 3, square is 3. Square is 3, so 2 into 3. That's it. Yes or no? Done, Priyanshu? What is the answer? What is the answer? 6 minus 9 by root 2 is the answer. Is the approach clear? So see, right in the beginning, we have applied our Leibniz rule. When we are differentiating, we have applied our Leibniz rule. But after that, the entire manipulation that was happening was with respect to what do we need to find. I wanted f of something isolated. Once I got f of cos x, I again multiplied by cos x because I was in a hurry, or I was moving in this direction to plug in cos x as 1 by root 3. So 1 by root 3 f of 1 by root 3, or 1 by root 3 f dash of 1 by root 3. That is what I wanted to form. That was the expression I was chasing, and accordingly I was manipulating, accordingly I was multiplying, accordingly I was dividing. So it's not something to cram, it's just something to understand that if you know the destination, you will move accordingly. Okay? But I hope the application of Leibniz rule was perfectly clear here, because one of the limits was a variable. That is why in order to differentiate, we have used Leibniz theorem. Like, let's go to this one. Tell me quickly, how will you crack this question? This is a question where your integrand involves double variable. It's a double variable question. Yes or no? Double variable, theta also, x also. But please understand what is happening. This is theta equal to, this is theta equal to. So my variable of integration is theta. X is acting like a constant. Get this very clear, people. I am integrating with respect to theta. The limits are of theta. So theta is actually my variable. X is acting like a constant. This cos x part, I can straight away bring it out of my expression. And then I will be left with my integrand being of a single variable, which is theta. Whenever you apply Leibniz rule, please remember the very, very, very important disclaimer. Whenever you apply Leibniz theorem, your integrand has to be function of a single variable, not a double variable. Your function, the integrand has to be a function of a single variable. Right now, your integrand is a function. It looks like it's a function of x also, theta also. But no, it's not a function of x. No, x is acting like a constant. Pull it out. And you can pull it out. It's sitting in an explicit fashion. Cos x, you can individually just pull it out. And now what happens? Now this is pi square by 16, which is a constant, but x square is a variable limit. Cos x has come outside. Inside, I'm left with cos of root theta upon 1 plus sine square of root theta d theta. Now my integrand is of a single variable. I want y dash at pi. I want y dash at pi. And this is your y of x. I want to differentiate. In order to differentiate, what will I do? I will use the product rule, bache, because here I have two functions of x. This is one function of x, and this integral, when you will open, plug in the upper limit and lower limit, which are values of theta, eventually on solving you will get a function of x only, no? So both are functions of x sitting in the multiplication format, pointwise multiplication. So if I want to perform y dash x, I am interested in applying the product rule. First function, differentiation of second. In order to differentiate the second function, I have to use the Leibniz rule. Because I want to differentiate an integral whose one of the limits is a variable. So first function, differentiation of second, will give me cos of root x square upon 1 plus sine square root x square into 2x. Okay? Integrand of upper limit into dash of upper limit minus integrand of lower limit into dash of lower limit. Dash of pi square by 16 will be 0. So no need to write the minus quantity. This part is done. Plus second function, which is pi square by 16 and x square, cos of root theta upon 1 plus sine square root theta d theta into dash of the first function, which is minus sine x. Check this. The moment you plug in x as pi, plug in x equal to pi here, plug in x equal to pi here, plug in x equal to pi here. The moment you plug in x equal to pi, sine pi is 0. So this complete quantity becomes 0. Okay, and from here when you solve, your answer comes out to be 2 pi. That's your answer. So this was an easy question. Trust me, this was an easy question, but you had to realize very, very carefully that first of all, your integrand looks like function of two variable x and theta. But actually, it's just a function of theta. Your variable of integration is theta. X is acting like a constant. Please pull it out if possible. The moment you pull it out, now you have one function of x, which is cos x, and this complete integral, which on resolving will come out to be a function of x only. So two functions of x sitting in multiplication. If you wish to differentiate, you will have to use the product rule. First function, differentiation of second, plus second, differentiation of first. But when you go to differentiate this integral wala function, you have to use the Leibniz rule. Because this integral wala function has one of the limits as a variable limit, x square. If both limits are constant, it's a definite integral question. But if one of the limit, at least one of the limits is a variable limit, you use Leibniz rule. Hashtag HDCC. Well, just 10-15 more minutes, not more. Let's go. I have a couple of very nice questions to discuss with you. So I really wish to discuss them, like this one. Fantastic question here. Like supremely fantastic. Let me rewrite it. This is limit x tends to pi by 2 integral 0 to g of x. This is 1 upon root over 1 plus t cube dt upon integral pi by 2 to x sine square mu d mu. So don't look at this. Look at what I've written below. Integral upon integral. Integral upon integral. Now see, I have to compute this limit. This is a very, very famous category. Very famous, highly repetitive category for your JEE Main exam. Highly repetitive. So many concepts involved. See, this is limit of one function upon another function. Always check the form. When you plug in x as pi by 2, what happens in the numerator? What happens in the denominator? When you plug in x as pi by 2, what do you get? When you plug in x as pi by 2, what do you get? You get 0 to g of pi by 2 and whatever here. And when you plug in x as pi by 2, here you get pi by 2 to pi by 2, whatever is here. What is g of pi by 2? Please check. What is g of pi by 2? G of pi by 2 is 0 to cos pi by 2. Cos pi by 2 is 0. 1 plus sine t square. Oh my god. 0 to 0 answer is 0. So g of pi by 2 is 0. Now 0 to 0 integral is 0. No. That means this limit is coming out of the form 0 by 0. Oh, such a smart question, yaar. I wanted to compute g of pi by 2, for which I had to go to this piece of information. Plug in excess pi by 2, I will get 0 to 0, which is 0. 0 to 0, any integral gives you answer as 0, no? So my limit is coming out of the form 0 by 0. So now I will apply LH rule. Differentiate the numerator, differentiate the denominator. When you differentiate the numerator, because one of the limits is g of x, which is a variable limit, you will have to use the Leibniz theorem. So integrand of upper limit into dash of upper limit, 1 upon root over 1 plus g of x whole cube into g dash x. Integrand of upper limit into dash of upper limit minus integrand of lower limit into dash of lower limit. Dash of 0 is 0, so I will not write it. Correct? Correct? Cool. I have differentiated the numerator. I have differentiated the numerator. Upon differentiate the denominator, sine square x into 1. Sine square x into 1 minus sine square pi by 2 into 0. Same thing. Same thing. Now there is limit x tends to pi by 2. Correct? Now let's again check the form of the limit. What will you get? G dash pi by 2 upon root over 1 plus g of pi by 2 whole cube. Now g of pi by 2 whole cube is 0 only. Root 1 is again 1 only. So I am going to get upon sine square pi by 2. Right? Sine square pi by 2 again is 1 only. Na? That means this is coming out to be g dash pi by 2. Oh, and what is g dash pi by 2? The limit bachche is coming out to be g dash pi by 2. What is g dash pi by 2? See, g of x is 0 to cos x 1 plus sine t square dt. So g dash x, again use the Leibniz rule. It is 1 plus sine of cos square x, 1 plus sine of cos square x into all of this multiplied with minus sine x. That's it. I am again and again applying the Leibniz rule. So g dash pi by 2 will give you 1 plus, what is cos pi by 2? 0. Sine 0, 0. So 1 sine 0, 0. So 1 plus 0 into minus sine pi by 2 is 1. So minus 1, this gives you minus 1. Minus 1 is the answer. Such a brilliant question. I mean, just look at this. First step was to check the form of the limit. It came out to be 0 by 0. Next was apply the LH rule. When you go to apply the LH rule, you have to, as a result, differentiate the numerator and differentiate the denominator. Differentiate the numerator and differentiate the denominator. In both the steps, you have to apply Leibniz rule. When you did that once, when you applied LH rule once, your answer came out to be of which form? Again, you check the limit. Limit came out to be g dash pi by 2. Right? It was no more 0 by 0, infinity by infinity, anything. It was a fixed finite quantity g dash pi by 2. Now, your aim was to determine what this quantity is. So, you moved again to g of x, computed g dash x, for which again you applied Leibniz rule, and bingo, you had minus 1 as the answer. Correct? Hashtag HDCC, everybody. Alrighty, let's go to this question. And this is the second last question. After this, we have the last question. Okay, this is second last. After this, we have the last. Okay, this is one of the most important and fresh variety of question. Why fresh? Because again, there is the same panga. Again, the same panga that your integrand is looking like a function of two variables, na bachche. It's looking like a function of two variables. Tell me, isn't it? Please tell me, isn't it looking like a function of two variables? Yes ma'am, no ma'am. See, f of x is equal to 0 to x e to the power x minus t f dash t dt minus integral 0 to x square minus x plus 1 into e to the power x dx. Oh, no, 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 no. This is not under integral. Okay, only this much is under integral. Minus, this is separate, x square minus x plus 1 into e to the power x. Okay. Only this much part is the integral part. Now you please see, I want to compute minimum value. If I want to compute minimum value, somehow AOD will come into picture. AOD means I will have to differentiate, compute the critical points and then check whether which one is point of minima, maxima, whatever. But I have to differentiate in the first place. No, in order to differentiate, I will have to differentiate this also. If I wish to differentiate this, I am trapped. Because if I wish to differentiate this, my integrand is looking like a function of two variables, x and t. I can't apply Leibniz rule until and unless my integrand is a function of a single variable. Right? Here see, one limit is 0, one limit is x. X is a variable. So to differentiate, I will have to use the Leibniz rule. But when I use the Leibniz rule, my integrand has to be a function of the single variable. Right now, please realize, just like I told you in the second question that we did under Leibniz theorem, that this is an integral with t as the variable of integration. These are limits of t, bache. These are limits of t. So x is acting as a constant. You can clearly write this as f of x equal to integral 0 x e to the power x into e to the power minus t f dash t dt. This completely can be chucked out. And then you will be left with the integrand of a single variable. This is the trick, this is the catch to crack such questions. Minus of x square minus x plus 1 into e to the power x. So once this comes out, this gives you e to the power x integral 0 to x e to the power minus t f dash t dt minus of x square minus x plus 1 into e to the power x. Okay? Now when I compute f dash, the fun starts. Why? Because this is again function of x into function of x. In order to differentiate this, I will use the product rule. Function of x, product rule. Let's start. F dash x. We'll start. First function. Differentiation of second. Use the Leibniz rule. E to the power minus x into f dash x. Differentiation of second. No, integrand of upper limit into dash of upper limit minus integrand of lower limit into dash of lower limit. Okay. Plus this integral, which is 0 to x e to the power minus t f dash t dt into e to the power x. Correct? First function differentiation of second plus second into differentiation of first minus again x square minus x plus 1. First function into differentiation of second, second differentiation of first. Alrighty, what next? E to the power x minus x, e to the power 0 is 1. You are just left with f dash x here, right? Plus, what is this completely, bache? You can bring e to the power x inside, you will be left with e to the power x minus t into f dash t. And e to the power x minus t into f dash t, e to the power x minus t into f dash t from 0 to x is equal to what? Huh? It's what? It is f of x plus this complete expression. No. Go to the question. Come on. 0 to x, e to the power x minus t f dash t dt. This part written in the question is nothing but, it's nothing but f of x plus x square minus x plus 1 into e to the power x. Rest is minus of x square minus x plus 1 into e to the power x minus e to the power x into 2x minus 1. This and this gets cancelled. F dash cancels. F of x simply comes out to be e to the power x into 2x minus 1. Bingo. Bingo. Beauty, beauty, simple beauty. F of x is e to the power x into 2x minus 1. I have to compute its minimum value. Now that I have my f in picture, I will compute its minimum value. Okay? Okay, let's start. F dash x. First function, differentiation of second, plus second, differentiation of first, equal to 0. E to the power x common, 2 minus 1, 1. 1 plus 2x is 0. So 1 plus 2x is 0. So x comes out to be what? Minus half. Please check. The moment you say x is minus half, but obvious, x is minus half, this will be plus, this will be minus. So this is point of minima. And hence the minimum value will be f of minus half. Getting it? Minimum value will be f of minus half, which is e to the power minus half. 2 into minus half will give you minus 1. Minus 1 is minus 2. Okay? Minus 2 upon root e. How many of you all are getting this answer? Yes, this is the only trick part. Trust me, Kaushal, trust me, Priyanshu, this is the only trick part of this question. Let's see, when you are differentiating, the moment you are differentiating, this portion actually is getting replaced with the question, because this portion is resembling this part of the question, which is nothing but f of x minus this part. That's it. This replacement is the only catch part of this question. Otherwise, it's a cakewalk. It's a cakewalk. Last question, everyone. Please brace yourself. JEE Advanced 2018 was repeated in JEE Main 2019. This is one of the highest weightage questions again. Listen to me carefully. In the previous question, what happened? When you were computing f dash x, by mistake, I should say, or maybe fortunately, I should say, f dash itself got cancelled out. Remember? F dash got cancelled out. And that is that directly you got f. Sometimes what happens is f dash doesn't get cancelled out. And what you end up getting is a differential equation on solving which you get f. So in this question, good thing was f dash only got cancelled out and we directly got f. But now let's check out this next question. Here, f dash will not get cancelled out and we will have a differential equation on solving which we will get f. So I'm making you solve all the varieties, okay? What is written here? F is from close 0, infinity to r. See, what is f of x? Very important. 1 minus 2x plus 0 to x e to the power x minus t f of t dt. Again the same panga. My integrand should not be a function of two variables. It should be a function of one variable if I want to differentiate it. If I wish to differentiate it, it should be a function of one variable. One variable, and I want f of 1. Remember, in order to get f of 1, I want the definition of f. In order to get definition of f, I will have to first differentiate, because f is trapped inside integral, na? F is trapped inside integral. If I differentiate the integral, then my f will be released, because differentiation and integration are inverses of each other. So when I differentiate my integral, my f will be released. So I will have to differentiate. Let's differentiate. But before differentiating, realize when you will reach here to differentiate, you can't apply the Leibniz rule, because my integrand is a function of two variables. So what will I do? F of x is equal to 1 minus 2x plus e to the power x outside 0 to x e to the power minus t f of t dt. The same drill that we followed in the last question. Actually, this is just a function of t. X is a constant. Pull it out. Pull it out. Now this integral involves integrand of a single variable t, and now I can differentiate. When I differentiate, I get f dash x is equals to minus 2 plus product rule. First function, differentiation of second, which is e to the power minus x f of x into 1 plus integral 0 to x e to the power minus t f of t dt into differentiation of e to the power x. E to the power 0 is 1, you get minus 2 plus f of x. And what is this again? Same thing. What is this again? It is resembling this complete part. So it will be f of x minus 1 plus 2x. f of x minus 1 plus 2x. f of x minus 1 plus 2x. See? So f dash x comes out to be 2 times f of x plus 2x minus 3. Isn't it? Isn't it? This is like dy by dx is equal to 2y plus 2x minus 3. Isn't it? If I take y as f of x, I have dy by dx is equals to 2 times y plus x minus 3. This is exactly what I was talking about. This time in this question, you did not get directly f. You got a differential equation. You got a differential equation, which now you have to solve to get y, which is f of x. So let's start. Y plus x is equal to t. dy by dx plus 1 is equal to dt by dx. Yes or no? So this gives you dt by dx minus 1 is equals to 2t minus 3. Or you can say dt by dx is equal to 2t minus 2 or twice of t minus 1. That's it. dt upon t minus 1 is equal to 2 dx integral. Can you solve this? Can you solve this? People, quickly tell me. Can you now solve this? This is log of t minus 1 is equal to, what is this? 2x plus c. And now comes the most important part, which is where to bring the initial value condition from in order to plug in the value or in order to find out the value of c. How to reach the initial value condition which we will use to get c. Because every time when we solve differential equation, we have to somehow compute the value of c, which we do using initial value condition. But that is not given here. It is given. It is given. Whenever you get such questions, always remember, you plug in x to be the lower limit. You take x to be that value which makes the integral vanish. You have 0 to x, so you will take x to be 0, so that your integral becomes 0 to 0 and it vanishes. If suppose you would have had 1 to x, integral 1 to x, you would have taken x as 1, so that integral becomes 1 to 1 and vanishes. If it was 2 to x, you would have taken x as 2, so that integral becomes 2 to 2 and it vanishes. So your initial value condition will come from what? It will come from taking x to be that value which makes the integral vanish. Right now we have 0 to x, so take x to be 0, and I can take that because my domain has 0. So f of 0 gives you 1 minus 2 into 0 plus 0 to 0 integral will be 0, and your initial value condition is here that f of 0 is 1. This is magic. We were not given the initial value condition, we have obtained it. So here I get log of, what was t? X plus y. Minus 1 equal to 2x plus c. Now f of 0 is 1. When x is 0, y is 1. When x is 0, y is 1. So what do you get? Or rather you can write it like this. X plus y minus 1 is e to the power 2x into e to the power c. Let's take it k. Right? Now you plug in x as 0, y is 1. So 0 comes out to be e to the power 0 is 1. So k is 0. Please check, if k is 0, plug it over here. What do you end up getting? X plus y minus 1 is 0. That means x plus y is 1. Or you can say y is 1 minus x, or f of x is 1 minus x. The moment f is obtained, now I can compute anything that the question demands from me. F of 1 will be 0. It needed f of 1. So realize in the previous two questions, whatever we've done, they are kind of similar, but kind of not same. Kind of similar. In the previous question, we have computed f dash, very true. And we have again then also did the same thing. Whenever you are trapped with this integral part, reach to the question and replace it with something which doesn't involve integral. The integral part will be replaced with f of x minus 1 plus 2x. Like here, similarly in the previous question, we have replaced that integral part with the respective remaining part of the question. Correct? That much part was same. Correct. But on resolving, we saw f dash got cancelled out in the previous question and we directly got f. Here, f dash did not get cancelled out. Did you see? F dash remained, very much remained, and that gave rise to a differential equation, which we solved and got f. But when you solve a differential equation, you end up getting an unknown constant. Till the time you don't reach the value of this constant, you can't compute f. So how to reach the value of this constant? By using some initial value condition, which is not given here, but indirectly given here. How? Take the value of x to be the lower limit. The moment you take x to be 0, your integral vanishes and you end up getting f of 0 equals 1. This is your initial value condition. Using that, you got your constant, and that is how you got your function. The moment you get your function, you can compute anything related to that function. I hope this is absolutely clear. And with that, it's a wrap, people. This is your homework question. Make sure you compute the answer of this question. The question is very amazing. 2021 PYQ. Try to not look in Google, look anywhere in your module, anywhere if you have solved this, anywhere in your book of PYQs. Please sit and solve this. It's a very similar question like we've done. You only have to differentiate, and then compute this limit. All right. When you differentiate the given equation, this equation, you will end up getting f. When you plug in the value of f, you will end up getting the limit. So it's a very beautiful flow. Just keep following, keep applying the concepts, keep applying whatever learnings you've taken from today's class and crack this question. Let me know in the comments what is the answer you are getting. Also, people, also listen to me. Limit as a sum, reduction formula, and inequalities involving definite integrals. These three topics are primarily question-based topics. There's not much theory here. Just like in Leibniz, you saw there was not much theory here. But Leibniz we did today. Otherwise, these three topics, limit as a sum, reduction formula, and inequalities, I will be posting videos of all the three topics with the best questions involved that you can do to ace these topics. Okay, whatever results, formulas, tricks, and questions you must practice, I will be discussing in the videos. So make sure you subscribe to the channel, because once you watch all these three videos, also apart from this one shot, your definite integration will be full on complete, 100%. Okay, so we've done till Leibniz, but the reduction formula, limit as a sum, and inequalities, I will be posting 3 short videos, not very long. Just watch them. Solve the questions which I'm doing in those videos. You've seen how much beautiful variety we've covered in the entire one shot today. The same beautiful variety I will be covering for all these 3 topics as well. And so please watch these videos, solve all the questions. If there's any query, let me know in the comments below. And also make sure you join the Telegram group, Study with Bhoomika Ma'am. All right. On this note, very good, Priyanshu, that's also done. If you use LDE, that's also cool. But again, to compute the constant, you will have to use the initial value condition, which you will find out. It is not visibly given to you, it's indirectly given to you. Okay, always plug in x to be that value which will make the integral vanish. That means plug in x to be the lower limit. So that lower limit, upper limit matches, integral vanishes. From there, you get an initial value condition. Big takeaway. Okay, on this note, it's me, Bhoomika, signing off, guys. Let me know if there is any other pain point you want me to come and discuss on the channel. Comment section is free for your thoughts. Please feel free to say good words, and please feel free to also write down your pain points. I'm going to see you super soon again. Take care. Keep learning. Bye-bye.